don't have anything right on the tip of my mind this second to start with consensus-wise, but one option is always just to like dive into a paper, or I'd love to hear anybody else's suggestions.
Yeah, I'm okay with that because I didn't have time to read it.
Yeah, likewise. Well, I think we dropped some links last week. Let's see. Tomislav, you dropped some YouTube videos that I planned to watch, but then forgot to watch. But
yeah, the first one is a playlist. For each different consensus, he explained how it's working. So yeah.
Okay, cool.
But very, very short videos for a few minutes each.
Oh, nice. Okay. Yeah, good. Well, we could dive into Hashgraph, or we could dive into Casanova, or let's see. Isaac had mentioned at one point maybe diving into like Bitcoin paper and looking at how their proof of work worked. What is everybody in the mood for?
Graph is from Dallas, so I've been to all their conventions and stuff. Definitely looked through their consensus. It's not like the most complicated thing, but I don't understand it. It's an interesting one.
That was Hashgraph, Joe?
Yeah, it's Hashgraph.
Okay. Anybody opposed?
I like Hashgraph.
All right. Let's take a look at the Hashgraph paper. Personally, I have never read this, so let's just see here. I did listen to an Epicenter podcast, though. I thought maybe that was going to load the paper. But...
Yeah, I watched it also.
Oh, there it is. Okay.
So I have to ask, do you guys now understand CBC Casper well?
Yeah, I feel like we have a pretty solid understanding of CBC Casper. What do you guys think?
Yeah, I'd agree that we have a solid foundation at least, and we understand, up to blockchain consensus and quite possibly even the block tag consensus.
Cool. Is it as complicated as it seems when you started?
I think the diagrams help immensely.
Yeah. We came up with a pretty nice way to visualize or it's not really that brilliant. It's a DAG. Everybody draws a DAG the same way, right? Boxes and arrows. But just sorting things into columns for what validator created what blocks and labeling the estimates on the blocks. And then for blockchain and block DAG consensus, we visualize it as two separate diagrams where one is the justification DAG and then the other one is the actual like blockchain or block DAG. I think that helped us a lot.
Yeah, definitely. Okay. Anytime you can, create a diagram from some abstract nonsense, it always helps.
Yeah, I should consider writing an article on it or something.
Yeah, nice.
Oh, that's not a bad idea. Okay, so let's see. Let's dig into Hashgraph here, or maybe let's read the abstract and then go from there. So maybe I'll give it a start, and you guys can think about who wants to read the next chunk. So this is from 2016, so we're 2.5 years later. A new system, the Swirlds Hashgraph consensus algorithm, is proposed for replicated state machines with guaranteed Byzantine fault tolerance. It achieves fairness. So, okay, I'm curious to hear what fairness means. Oh, here we go. In the sense that it's difficult for an attacker to manipulate which of two transactions will be chosen to be first in the consensus order. It has complete asynchrony, no leaders, no round robin, no proof of work, eventual consensus with probability 1, and high speed in the absence of faults. Okay, so that makes it sound like maybe if the more faults, the slower it gets, but kind of like Derek was saying, in the common case where most people are playing fair, it's pretty fast. It's based on a gossip protocol in which participants don't just gossip about transactions, they gossip about gossip. They jointly build a hash graph. I'm pretty sure the hash graph is basically a DAG, but I don't know that for sure. reflecting all of the gossip events. This allows Byzantine agreement to be achieved through virtual voting. Alice does not send Bob a vote over the internet. Instead, Bob calculates what vote Alice would have sent based on his knowledge of what Alice knows. This yields fair Byzantine agreement on a total order for all transactions, with very little communication overhead beyond the transactions themselves.
Oh, that's interesting. So they're going for a total ordering of their transactions here?
That was the thing that stood out most to me, too. I didn't expect that.
Yeah, interesting. So they're only building a blockchain then, right?
Well, I don't know. That's a good question. I really thought it was more DAG-like, but we'll figure out, I guess. But yeah, definitely.
But this is not. But this is order of these virtual votes.
Oh, order of virtual votes. Oh.
Yeah, because you want to know who sent in which order.
Well, it says. Okay.
Yeah, it says order of all transactions, though.
But the transaction is not the transaction. Transaction, I think he means the message.
Okay.
But you're repeating the same message, but when you are getting message like with the gossip, you're getting messages from other nodes, and you're sending like randomly to other nodes. And yeah, I mean, I'm talking about how this guy explained this on the video.
Mm-hmm.
You know, you're getting different messages from different nodes, and you're calculating what is the order of these messages, because you're having like a bigger picture.
Right. So you have partial knowledge of what everyone else knows. Okay,
Yeah.
and so you can say, well, Josh will vote A and Thomas will vote B, and you total up all the votes. And whatever has the most votes is the next block.
Exactly, but you're never sending the votes.
You're never
Okay, so
sending votes. The votes don't go on any chain. You just keep track of who knows what.
Exactly.
So it sounds like maybe what Isaac was saying is right then. Like it really is more of a blockchain than a block DAG. Oh, well, you're saying there is no blockchain. There's just who knows what.
Well, who knows what determines their vote determines the next block, and that evolves. I'm not sure how what the completion criteria is. They say the probability of 1 it completes.
Yeah, eventually.
It only can really complete if you have complete knowledge. If everyone knows what everyone else knows.
Okay, cool. So that's a pretty good sharing of our how we take that abstract, I guess. Is this the whole contents? Yeah. Okay. So here's the table of contents. Core concepts, gossip about gossip. Yeah. Okay. All right. Cool. Let's just keep going, I guess. Anybody want to take this next one?
Sure, I can read for a little bit. So distributed databases are often required to be replicated state machines with Byzantine fault tolerance. Some authors have used the term Byzantine in a weak sense, such as assuming the attackers will not collude or that communication is weakly asynchronous. In this paper, Byzantine will be used in the strong sense of its original definition. Up to just under 1/3 of the members can be attackers. They can collude, and they can delete delay messages between host members with no bounds on the message delays. The attackers can control the network to delay and delete any messages, though at any time, if an honest member repeatedly sends messages to another member, the attackers must eventually allow one through. It is assumed that secure digital signatures exist, so attackers cannot undetectably modify messages. It is assumed that secure hash functions exist, for which collisions will never be found. This paper proposes and describes the swirl's hash graph consensus algorithm and proves Byzantine fault tolerance under the strong definition.
Okay, cool. So I think that's the Byzantine definition we're probably more familiar with, that we've used most of the time here.
Yeah.
It assumes some pretty standard cryptographic primitives that I think we're all pretty comfortable with.
Yeah.
This part was interesting to me. The attackers can control the network to delay and delete messages, though at any time if an honest member... Yeah, right. So the attackers can control the network. So that seems like, you know, we're assuming, or we're preparing for a case where like the Byzantine actors here, it's a much bigger conspiracy than we thought. And they're actually like, you know, if we're building this thing on the internet, they're like controlling it. Or if we're building it on some internal network, they're in charge and they can like arbitrarily censor or drop messages or whatever.
But I'm not sure that he's talking about this situation.
Okay.
Because I'm thinking that he's talking about that honest member sending messages to this node, but this node don't report that he received this message from this node. But I don't think that this attacker node can have control of the network. He only don't like include these messages from these honest nodes in his block or transaction. But he said that eventually attacker must allow one message through. But
yeah, right. That seemed weird to me too. But
Yeah.
why?
It's a little strangely worded. It's not very precise, I guess. But what are they talking about by like repeatedly sends messages? Like is
I'm thinking that he sends with the gossip
Twice.
protocol. He sends messages to this node because you are sending this message to this node and you don't see your message when this node gossip to other nodes.
Yeah, exactly. It's not so much like it's controlling the network. It's that if it doesn't relay messages, then maybe it can be flagged for that.
Yeah.
So let's say like me and Jay are honest participants here, and I'm trying to send some message over to Jay. I took this first part right here to mean that the attacker could like literally stop my message from reaching Jay. But then I was confused at the second part, because then it kind of like backpedaled on that. It was like, well, if Joshy's really persistent enough and sends it like over and over and over and over and never does anything else, then eventually that has to get through to Jay. One of them has to get through.
I mean, I think it still could kind of be like that. It's like if you're gossiping to an attacker and the attacker doesn't relay your gossip and you're continuously doing that, but you're also gossiping to another person, then ideally everyone will eventually realize that attacker.
Okay. Yeah, that makes sense. The other thing I wanted to note in here was no bounds on message delays. So that's different than what Derek was saying about Casanova the other week, where they had that capital delta that's basically like, we don't know how long it is and it could be really long, but eventually a message you know that if you send a message, it will arrive within this time limit delta, whereas here they're saying you don't have to make any assumption like that.
Yeah, what do they call that in Casper? It's like liveness or something?
Yeah, so Casper didn't have that, and they're having trouble proving that it's live, I think is the situation. But then Casanova added it, and they proved it was live.
But in Casanova, they're saying that they're proving synchronous consensus, not asynchronous. Because
I think they called it partially synchronous, right?
Or partially synchronous.
Yeah.
Right.
I think that. Mm-hmm. No, go ahead.
I mean, he's saying that this strong definition means asynchronous consensus.
Oh, that's part of the Byzantine definition.
Yeah.
Okay.
And
I think. Oh, sorry. Go ahead.
I was just want to say that I remember that this guy was saying that you cannot prove asynchronous consensus. But you can prove if you have some kind of non-determinism or like I I'm thinking about some kind of random generator or hash, then you can prove it that has probability 1.
Oh,
And
that's
I'm not exactly sure what that means.
well, we do have a hash to work with. Okay, you guys want to keep going?
Yeah. Oh, yeah. The only thing I wanted to say is I think that assumption of some finite bound on message delivery time is partial asynchrony, or partial synchrony rather.
Yeah,
Like
that
having
sounds right.
having this. Yeah. Like having this condition where like there's no bound on message delays, like that is what an asynchronous.
Yeah. Okay, cool. All right, who wants to take that next one?
I'll go for it. So no deterministic Byzantine system can be completely asynchronous with unbounded message delays and still guarantee consensus by the FLP theorem, which anybody know what that is?
We've looked at it a few times. I wouldn't personally mind if you could give us a good reminder, though.
I don't.
Okay. It's one of those things where there's like 5 or 6 or 4 or 3 desirable criteria, and you can have n-1 of them simultaneously, but I forget what they all are.
Okay.
Isaac, do you have a number, or Tomislav?
This is a paper which says that if you have only one node fault, you can get consensus.
Okay. Okay.
Yeah.
But it is possible for a non-deterministic system to achieve consensus with probability 1. The hash graph consensus algorithm is completely asynchronous, is non-deterministic, and achieves Byzantine agreement with probability 1. Some systems, such as Paxos or Raft, use a leader, which can make them vulnerable to large delays if an attacker launches a denial of service attack on the current leader. Many systems can even be delayed by just a single bad client. In fact, the latter paper suggests that systems with such vulnerabilities might be better described as Byzantine fault survivable rather than Byzantine fault tolerant. Hashgraph consensus does not use a leader and is resilient to denial of service attacks on small subsets of the members.
All right. So, Thomas, that sounds like kind of what you were saying about like we need some non-determinism in here to get around FLP.
And then when, I'm thinking about Casper, and Vlad is saying, okay, we will not assume anything, not determinism. So you cannot prove if you're not assuming something like that, right?
Yeah,
I mean,
approach a probability of 1, but there is no assumption, as far as I know, in FLP that that it's deterministic. In fact, networks are notably non-deterministic.
What exactly does deterministic mean in this context?
but I mean that the deterministic means if you are making consensus of some deterministic thing.
Yeah.
Oh, okay, I see. Like the virtual machine is deterministic?
Yeah, the state of virtual machine, but you want to have something non-deterministic.
Oh, I was taking it more to mean that, like, whatever algorithm the nodes in this hashgraph network are going to be running, they're allowed to roll dice in deciding how they're going to act. That's how I was taking that deterministic.
Yeah,
Whereas, like,
reasonable. The idea being that, well, for example, you can't break a tie deterministically in a network.
yeah, unless there's more information. Like when Isaac was suggesting a few weeks ago when we were doing binary consensus, like if we have a tie for score wise, maybe we can like use a hash of the block and like the lower hash is the tiebreaker. Oh, but maybe that's like the non-determinism then. Well, it still seems deterministic though if it's a hash function.
Yeah, but you can have some seed which is random.
Hmm. Okay, cool. So
Can someone explain this probability one?
well, probability is a number between 0 and 1. You're talking about I lost where that part was.
Paragraph above.
This part right here.
Yeah.
Okay, right. The hash graph consensus algorithm is complete. Well, one thought I had was like we've got this baseline FLP theorem that everyone seems to agree with, and based on our answer to Jay's question, we probably should look more carefully into. But it seems like the way that Casanova handled that and said like, well, we're going to do something interesting despite FLP was by introducing a time bound, and then Hashgraph is saying we're going to do something interesting despite FLP by introducing non-determinism, whatever that means.
Yeah.
Well, okay, maybe we should just press on and that stuff will become clear.
I can read the next. Other systems such as Bitcoin are based on proof-of-work blockchains. This avoids all the above problems. However, such a system cannot be Byzantine because a member never knows for sure when consensus has been achieved. They only have a probability of confidence that continues to rise over time. If two blocks are mined simultaneously, then the chain will fork until the community can agree on which branch to extend. If the blocks are added slowly, then the community can always add to the longer branch, and eventually the other branch will stop growing and can be pruned and discarded because it's stale. And this leads to efficiency in the sense that some blocks are mined properly but discarded anyway. Yeah. It also means that it's necessary to slow down how fast blocks are mined so that the community can jointly prune branches faster than new branches sprout. That is the purpose of the proof of work, but requiring that the miners solve difficult computation problems to mine a block, it can ensure that the entire network will have sufficiently long delays between mining events on average. The Hashgraph consensus algorithm is equivalent to blockchain in which the chain is constantly branching without any pruning, where no blocks are ever stale, and where each miner is allowed to mine many new blocks per second, without proof of work and with 100% efficiency. This pretty much makes sense.
Yeah, I think that makes sense too.
That seems so weird though, because we were saying at the beginning, it sounded like they were shifting a blockchain because they wanted to totally order the transactions. But then, I mean, I don't know, maybe I'm misunderstanding what's being said here, but now it seems like we're very much not totally ordering transactions and everybody's in their own thing. But like I said, maybe I misunderstood this last paragraph.
Yeah, you're right. We will definitely have a DAG, but I'm thinking that we can analyze the DAG and we can see like only one way how messages are flowing to all the graph.
Mm-hmm.
Yeah, like I'm thinking if we have it sounds now like they have a DAG here, or at least a tree. I guess I don't know for sure if you can merge them back together. But in any case, like as long as there's some additional rule, we can get a total ordering. We don't have to change them all together into one hash chain to get a total ordering. We just then, like if we want to get a total ordering on transactions and parallel branches, we just need some kind of rule about like how we know whether, you know, transaction that came from this branch of the tree defeats the transaction from this branch of the tree or something like that.
Yeah. Well, and maybe I'm just thinking about the wrong thing too, because I think they might just be talking about the gossip here. Right, so you definitely have a DAG of gossip, like justifications or whatever.
Exactly.
Yeah, with the transactions, maybe we put them somewhere else where they're totally ordered or something. I'm not really sure.
Yeah, here's saying that they are sending gossip about gossip.
Yeah.
Yeah.
But in a sense, I think this is like a very similar to Casper. Or in other words, I think that Casper is just a generalization of this consensus. If you put, you know, non-determinism and
Well, right, because
That kind of message.
gossip and justifications are like the same thing, right?
Yeah.
Okay, all right.
I'll take the next one. Proof of work blockchains also require that electricity be wasted on extra computations and perhaps that expensive mining rigs be bought. Proof of expired time system can avoid the wasted electricity, though perhaps not the cost of mining rigs. By using trusted hardware chips that delay for long periods, as if they were doing proof of work computations. However, that requires that all participants trust the company that created the chip. Such trust in chip vendors exists in some situations, but not in others. Such as when FreeBSD was changed to not rely solely on the hardware RD-RAND instruction for secure random numbers because we cannot trust them anymore. I feel like that makes pretty good sense.
Yeah.
All right. Gary, you want to take one?
Sure. Byzantine agreement systems have been developed for Byzantine agreement that avoid the above problem. These systems typically change many messages for the members to vote. For N members to decide a single yes/no question, some systems can require O to the N messages to be sent across the network. Other systems can require O to the N squared or even O to the N cubed messages crossing the network per binary decision. An algorithm for a single yes/no decision can then be extended to deciding a total order on a set of transactions, which may further increase the vote traffic. Hashgraph sends no votes at all over the network because all voting is virtual.
Okay, let's talk about that a little bit. So I think I get why a yes/no decision would be O of N, right? Like if I make a proposition like, hey, let's meet at a different time next week, and there's N of us here, like we need to take each of your votes and then tally them up. And then, oh yeah, and like, that's interesting. So one way would be like, if for whatever reason I make the proposal and we just trust me to count the votes fairly, then you all send your vote to me and I tell you the result. That would be O of N messages. But if you guys can't trust me to count the votes, then we would each have to send our vote to each of the other people in the group here, and that would be O of N squared. And then I thought about this too. Algorithm for a single yes/no can be extended to total ordering. And my thought there was like, well, imagine we just start with like 2 items, and the proposition is like item A came first. That's a yes/no vote. So now we've got a total ordering there. Then we try to add in a third one. Now we have yes/no questions. We say like, does this third one go before both, in between, or after both? And I guess that would be 2 yes/no votes.
Yep.
And then Hashgraph sends no votes at all because the voting is virtual. Okay.
But it sends some kind of hash of voting.
Yeah. So I think I remember from the epicenter that the guy was saying whenever you send a message, you're sending oh gosh, I can't remember, but you're sending more than like just the transactions. You're also sending information about like, this is the previous thing that I sent, and this is the most recent thing that I heard someone else say, or something like that. And then somehow you can string back together enough information to know like, oh, I don't need Jim to tell me whether he wants to meet at the new time. I can just see, based on what he knows, how he would have voted. And so no vote need to be cast or something like that.
So that's the gossip about gossip.
Yeah. Okay, should we continue?
But I wonder how you can trust what somebody sends you, the gossip about gossip. Like you get that information, and then.
Yeah, so they did say we have what was it? Some kind of signatures.
Yeah, they are assuming that.
Yeah.
You cannot change the message. You can be sure who sent the message.
Right.
Yeah. Well, yeah. They can modify the message, but they leave the.
But if it is, oh, sorry, Isaac, that you were breaking up a little bit. I might have stepped on you there.
Oh no! All I said is, yeah, they have to sign. So even if they do modify the messages, they can't do it. I mean, it just says undetectably, right?
Yeah.
Yeah.
So if we haven't read this yet, but I thought I remembered it. But if the rule actually is like I need to send the most recent message I've sent from someone else, I could send, maybe I received a message from Isaac, but I, for whatever reason, like don't want to send it or want to cheat somehow. And so instead I send like the second most recent message. That wouldn't necessarily violate any, or that wouldn't break any signatures, but it would still be not the protocol.
Yeah, that's interesting. It wouldn't break the order.
Yeah, well, you would need more than 1/3 of the people doing that in order for to have a Byzantine failure.
But it's very difficult to delay. You're delaying messages from some validator, but it's very difficult. You know, you will get other message from other validators that contain this message. So you cannot say, I'm not saying I didn't see this message, but I'm sending in the other block. You know?
Yeah. Right. Right. Okay. Okay. It looks like this is about to get interesting and dense. Core concepts. Who wants to take it? Or maybe we'll take a bullet point at a time. I'll do one here. Transactions. Any member can create a signed transaction at any time. All members get a copy of it, and the community reaches Byzantine agreement on the order of those transactions. So I guess I feel like there's some notion of transactions that's more than just gossip, right? Like we've got to be able to build some kind of application on top of this consensus algorithm, right?
Right. I mean, I don't even know if they necessarily said anywhere that gossip is a transaction.
Okay, yeah, right.
I mean, the transactions are just like whatever we're coming to consensus on, right?
Yeah, Bitcoin payments or smart contract calls or something like that.
Right.
Fairness, it should be difficult for a small group of attackers to unfairly influence the order of transactions that are chosen as the consensus. That's pretty easy.
Yeah.
Seems really reasonable. Gossip is information. Information spreads by each member repeatedly, choosing another member at random and telling them all they know.
Oh, okay. So there's two juicy details right there. At random, first of all. So I have to like.
Oh, is that where the non-determinism comes from?
It sure sounds like it, but then my thought is like, how can I ever prove that I chose genuinely at random? What if I'm just specifically and carefully choosing my other members?
Yeah.
Well, I guess maybe that's Byzantine
gossip. Since you gossip about gossip, then maybe you could prove that that's. I don't know. That seems kind of far-fetched.
Yeah.
Yeah, that would be the same thing about delaying a message. If you chose to choose a different order than random, then eventually somebody's going to defeat you by sending some gossip that you're forced to send.
Yeah, but it's kind of tough.
Otherwise, you've got a validator anymore.
That's pretty tough to prove that what you're sending is not random because I mean, unless you did some distribution analysis on there.
Yeah, but even then, you still can't really prove it. You can just say, again, with some confidence,
Yeah.
It doesn't seem like that's random because it's 27 heads in a row, but maybe.
It could be.
Yeah. Okay, cool. Hash graph. The other thing was all they know. I wasn't expecting that. So I'm not supposed to just say like some recent subset of things I learned, but like my whole state of the world, maybe?
Yeah, I wonder how that affects the bandwidth.
That's what I was wondering too. It seems like message sizes might grow as the network runs.
I'm thinking all they know as all other gossip about this section. This is what I was thinking.
You were thinking of it as all other gossip?
Yeah.
Yeah. Okay. All right. hash graph, a data structure that records who gossiped to whom and in what order. So that sounds like a DAG almost, I guess. Or, I don't know. I wonder if there'll be some diagrams.
Yeah, where are the transactions stored?
Oh, yeah, right. Do transactions go in the hash graph?
Doesn't look
Oh,
like it.
that looks like it's helpful. Let's just read through this list and then maybe we'll get to that. Okay.
It's a bit interesting though. So like with this gossip thing, it says choosing another member at random. So like you're only ever choosing one person to pass all of your information to.
Oh yeah, when do you do it?
But you're repeatedly choosing another member. So you're like a setting to all.
Okay.
Oh yeah, what does that mean? Like as fast as I can or as fast as I feel like?
As many as you want, maybe?
Yeah.
Yeah, I don't know. Okay, well, either way, gossip about gossip. The hash graph is spread through the gossip protocol. The information being gossiped is the history of the gossip itself. So it is gossip about gossip. This uses very little bandwidth overhead beyond simply gossiping the transactions alone.
Okay. Well, this very little bandwidth overhead seems to address my concern about sending all they know. I guess maybe we'll get details soon.
In his talk, he explains that you can send only hash, but not even the whole hash. You can just send one byte. I'm just repeating.
Yes, this is correct, or no, this is not. Virtual voting. So every member has a copy of the hash graph. So Alice can calculate what vote Bob would have sent her if they had been running a traditional Byzantine agreement protocol that involved sending votes. So Bob doesn't need to actually hear the vote. I'm assuming send her the vote. Every member can reach Byzantine agreement on any number of decisions without a single vote ever being sent. The hash graph alone is sufficient. So zero bandwidth is used beyond simply gossiping the hash graph.
All right. So I think the concept of like knowing what someone else would vote is familiar from Casper, although I guess in the Casper context, it's more like what they should vote. And then if that's not what they actually end up voting, then we slash them. Whereas here, we don't even have them send anything in the first place because we know what it's supposed to be. Alrighty. Famous witness. The community could put a list of N transactions into order by running separate Byzantine agreement protocols on O of N log N different yes-no questions of the form, did event X come before event Y? A much faster approach is to pick just a few events, which I guess are vertices in the hash graph, to be called witnesses, and define a witness to be famous if the hash graph shows that most members received it fairly soon after it was created. Then it's sufficient to run Byzantine agreement protocol only for witnesses, deciding for each witness the single question, is this witness famous? Once Byzantine agreement is reached on the exact set of famous witnesses, it's easy to derive from the hash graph a fair total order for all events.
Man, this is starting to seem really meta, like we're about to hit like Gödel's theorem or something.
What theorem was that?
Gödel's theorem,
Incompleteness theorem?
Yeah, basically, yeah. I mean, it's witnesses answering the question of whether they're famous.
Oh, Jay, are you familiar with these terms? You might have something to share here. I don't know. I've never heard famous in this context before.
No, I haven't either. I'm assuming, it's just, high reputation, like successfully, broadcasting true events.
Yeah. Okay. So I feel like I get the slower approach that he's describing. So a faster one is pick a few events to be called witnesses. So how do we pick them and how do we agree which ones they were?
Is this some kind of scoring or weights?
Yeah.
Yeah. says, define a witness to be famous if the hash graph shows that most members received it fairly soon after it was created. This is so loosey-goosey.
Yeah.
Most members fairly soon. How do I know when it was created?
Fairly soon, but this is a time related in asynchronous.
Yeah, right.
Well, can you draw any analog between a famous node and a what do they call it in Casper when a block is reached?
Finalized?
Yeah, maybe finalized. They have like another term for like a super finalized block or something.
So they have like the clique safety oracle, so we call them safe sometimes.
Yeah, maybe it's finalized, but yeah, basically just something that has enough backing behind it, or it can be proved that it, was ordered, after all these other transactions and has like 2/3 support behind it.
Yeah.
You're saying this finalized in a sense that you have total order for all events in hashgraph.
Yeah, I mean, it's more just that people have reached a consensus that something is true. So, I mean, like, once you hit the 2/3 mark for a block, you can call it finalized or something. And similarly here, like a famous node is one that's reached consensus in your local state of whether like they are, gossiping truth.
Yeah. Okay.
I can read the next one. Strongly seeing. Given any two vertices x and y in the hash graph, it can be immediately calculated whether x can strongly see y, which is defined to be true if they are connected by multiple directed paths passing through each members. This concept allows the key lemma to be proved that if Alice and Bob are both able to calculate Carol's virtual vote on a given question, then Alice and Bob get the same answer. That lemma forms the foundation for the rest of the mathematical proof of Byzantine agreement with probability 1. This is the same as in Casper.
Yeah, we had the concept of like seeing each other agreeing, I guess, right? In Casper.
Yeah, and not seeing each other disagreeing. Don't forget about that.
Yeah, right.
Yeah.
So here, okay, so X strongly sees Y if they're connected by multiple directed paths passing through enough members. Okay, all right. So I guess that just means like there's enough of us validators in this network who see that X came first, then we can say X strongly sees Y.
So a directed path means that like I gossiped to you, right?
That's what I was taking it to mean, yeah.
That's also what I was taking it to mean.
Yeah.
So do you think when they say, like that it's passing through enough members that this is like a Byzantine majority or something like that?
Yeah.
You mean like enough? Are you saying like?
Yeah, like, okay, at least, more than 2/3 of the validators have these paths going through them between X and Y, and therefore it's strongly seeing, or, something along those lines. Something more quantitative than enough members.
I assume that there's more quantitative definitions.
I would hope so. Yeah, paper ends, next page. All right. Well, I think that makes sense.
I have a question. If we have this kind of gossip, is this like this graph can be cyclic, right?
We
can start from
like X could gossip to Y, and then Y could gossip to X, right? And then there's a cycle.
Yeah.
There are two separate nodes, or three separate nodes, I guess. If you look at the graph below, because it's through time. So each node must have a time signature.
Yeah, so I think the vertices X and Y are like these little circles, and then the members are what we were calling validators before, I think.
Okay.
So so let's just pretend like for a second. Let's say this very top one that Carol sent is X, and then like I don't know, this one, second one over on the left is Y.
Mm-hmm.
I don't think, well, these don't even look like directed. Oh, shoot. This time goes the other way from what we're used to.
Time's going up.
Yeah.
Oh, sorry. Okay. So let's try that again then. Let's say X is this very one, the first one that Carol sent, and then like maybe Y is this middle Bob one right here. So are there any directed paths? Are we assuming there's always a directed path straight up within a single member?
Yeah, I think that makes sense, right? So you're never equivocating or whatever. You've always gossiped to yourself, basically.
Yeah.
Yeah, I could see that.
So I only see one directed path from Carol's first one to Bob's second, which is straight up and then diagonal left over to Bob.
Yeah.
Mm-hmm.
But like, okay, if we were using this Bob's most recent message, now there's a couple different directed paths. We could go up, left, up, or we could go up, up, left.
Yeah.
Yeah, okay. Okay, so gossip history as a directed graph. The history of any gossip protocol can be represented by a graph where each member is one column. When Alice receives gossip from Bob, telling her everything he knows, that gossip event is represented by a vertex in the Alice column, with two edges going downward to the immediately preceding gossip events by Alice and Bob. Yeah, I mean, I guess that makes some sense. So, like, if Bob gossips to Alice, this one right here, it has a line going back down to Alice's previous and back down to Bob's previous.
Yeah.
Oh, and that's true for all of them. Every one of these circles has one diagonal line going to another node, and then, like, implicitly, I guess, or hidden one that goes straight down.
Right. Yeah, so you're basically you're getting some packet of gossip from another validator or whatever, and then you're just doing like a union with like the gossip that you already have or something.
Yeah, it sounds like it.
Okay.
Yeah, I think so too.
Cool.
And so he just calls it a directive graph here, but I don't think we could ever get cycles in this.
Yeah, if you look at the time, yeah.
Okay.
Right, you'd have to be going backwards in time.
Yeah,
Well,
yeah.
if you send an anti-gossip to somebody, then maybe.
All right. Who wants to take that one?
I'll take it. Section 3, gossip about gossip, the hash graph. Hash graph consensus uses a gossip protocol. This means that a member such as Alice will choose another member at random, such as Bob, and then Alice will tell Bob all of the information she knows so far. Alice then repeats with a different random member. Bob repeatedly does the same, and all other members do the same. In this way, if a single member becomes aware of new information, it will spread exponentially fast through the community until every member is aware of it.
Yeah. So it sounds like everybody is just constantly choosing another random validator to send all of their gossip to.
Yeah, I agree.
Okay.
And basically as fast as they can, probably.
Yeah.
Is this the same thing that Kademlia now doing in the R node?
I don't really know how Kademlia works.
Well, I'm not sure also, but from what I heard, in different places, they are saying that this protocol is like a gossip protocol.
Oh yeah, for peer. Yeah. Oh, I think that's right. Like each person in the member or in the network maintains a list of peers, and then like when they hear about a new pair, they tell all their peers or something.
Yeah.
They don't choose at random. There is such a list of your peers, and they're kind of ordered by a notion of distance.
Oh, interesting.
What's up, Phil? I didn't know you were on the call.
Hey, what's up?
Yeah, hi, Phil.
Phil, do you want to read the next one?
Sure. The history of any gossip protocol can be illustrated by a directed graph like Figure 1. Each vertex in the Alice column represents a gossip event. For example, the top event in the Alice column represents
Sorry, Phil,
Bob.
I'm going to scroll it just for a sec. Oh, we can't see both. Okay, sorry. The top event.
For example, the top event in the Alice column represents Bob performing a gossip sync to Alice, in which Bob sent her all of the information that he knew. That vertex has two downward edges connecting to the immediate preceding gossips for Alice and Bob. Time flows up the graph, so lower vertices represent earlier events in the history. In a typical gossip protocol, a diagram such as this is merely used to discuss the protocol. There is no actual graph that like that stored in memory anywhere.
Oh, wow. That's good to know. No actual graph stored in memory. So that's very different than Casper, where we're definitely storing the DAG.
So that's confusing because you're still storing the state of all gossip.
But is this saying you're not storing, you're storing each gossip and not the whole DAG in each message? Because you can reconstruct it.
Yeah, how am I going to know how my peers are voting if I don't have that graph stored?
You can send only the hash.
Oh,
you can calculate what is the order. Sorry?
I just peeked at the beginning of the next paragraph. That graph is an actual data, in hash graph consensus, that graph's an actual data structure. Figure 2 illustrates the data structure. Each event, which is a vertex, is stored in memory as a sequence of bytes signed by its creator. For example, one event by Alice in red records the fact that Bob performed a gossip sync in which he sent her everything he knew. This event is created by Alice and signed by her and contains the hashes of 2 other events. Her last event and Bob's last event prior to that gossip sync. The red event can also contain a payload of any transactions that Alice chooses to create at that moment, and perhaps a timestamp, which is the time and date that Alice claims to have created it. The other ancestors of that event, which are gray, are not contained within it, but are determined by the set of cryptographic hashes. The data structures with graphs of hashes have been used for other purposes, such as Git, where vertices are versions of a file tree, and edges represent changes, but Git stores no record of how members communicated. The hash graph is for a different purpose. It records the history of how the members communicated.
Okay. So that's all it means by it doesn't store the actual graph, is it's just not literally explicitly storing the edges, but instead just the nodes, and you can reconstruct the graph.
Okay, that makes sense. Okay, so here's the figure they were talking about. So it started when Bob gossips to Alice, I guess, right? And so Bob sent Alice everything he knew about, which is this light gray stuff. But that's what I don't like. Does Bob actually literally send copies of all of these bytes of data? It kind of seems like no. Maybe just the fact that I'm not really sure.
Wait, how did they say that the data is being stored if it's not a graph? You just have like a bunch of gossip events and signed by who gossiped it?
Yeah, I think they're saying it's almost like a set of these vertices, and then the vertex itself, each vertex itself contains 2 like hash pointers that point back to, like in the case of this red one, point back to the 2 blue ones.
Okay.
Mm-hmm. Yeah, that's really similar to IOTA, if you've seen that one.
Oh, I know about IOTA a little bit, but not much about it.
They call it the tangle.
Yeah, IOTA is the one where you have to do validation to like participate at all, right?
Yeah, basically.
Okay.
Okay.
But this red one is created just like the same in Casper when we're doing blockchain consensus. We are just using these two parents and create another one.
Yeah.
Yeah, and it almost sounds like the payload that they're saying is like if Alice has like a queue of transactions that she wants to put into the block tag, then she can when somebody gossips something to her, but she doesn't have to. So it almost sounds like you know, like Alice can make an empty block if she wants, just like aggregating the gossip, or she can also add some unique, you know, like new stuff to it.
Yeah. Yeah, so like every one of these contains like 0 or more transactions, and when it's 0, it just contains gossip about gossip.
Right.
Yeah. That makes sense, and that's kind of similar to what you and I talked about offline, where like the reason people like to make empty blocks sometimes is so they can still participate in the consensus layer, even if they don't have any new transactions at the application layer.
Yeah, we were saying it's like a thumbs up, like your weight will go towards it, like whether or not you have transactions in the queue to publish or whatever.
Yeah. So it seems like that's a thing here too.
Yeah.
All right. So I'm realizing it's 11 o'clock right now, or whatever time it is, but the top of hour. Do you guys want to pause here and pick back up next week?
Yeah, sure.
That's good. Are y'all gonna do the same time next week?
Oh yeah, what does everybody think?
This time's fine for me.
Yeah, this time is perfect.
Do we need to send O of n squared votes?
Yeah.
It's fine for
Only
me.
hashes.
Yeah, that's right. All right. Same time next week.
Cool.
Thanks.
All right, cool. Anybody interested in staying on to talk about Rolang and Haskell for an hour?
Yeah, I'll probably join you guys.
Cool.
I'll definitely.
Okay.
Man, I would love to, but I gotta go.
Okay, cool. Good seeing you again, Jay. Good seeing you, Phil, Gary.
Yeah, take it easy, guys.
You hear
See you
me?
later.
Yeah. Jim, can we stop and restart the recording? Oh, is he still in?
He's on, but he may have stepped away.
Okay. All right. That's cool. That sounds good. Tomislav, do you want to start?
No. Do you remember the last time you said that you will say something about your implementation?
I'll go first. I haven't. The only reason I asked if you want to go is because I haven't really worked on it since last week, and it's not as fresh in my head. But I think it'll be fine.
Come on, man.
I can show you my example that are now it's working. So, but it's not deep.
Awesome! I saw that you had posted that second one.
Yeah.
I don't think I have a ton of interesting implementation stuff to show, but I definitely have a few questions that I want to ask of someone who's a better Haskell programmer than me, and luckily you are one.
I hope.
Yeah, well, I hope too. So, okay, let's see here. Maybe a good place to start is, well, I'll just start with main and we'll go from there. Not too much interesting in main. I import my other 3 modules, and then the main method is basically do this. The path to the program that we're gonna want to run is our first argument. So we grab the first argument, and we read its contents into this variable called program. So that's just a string. We send it through our parser that came from this module, row parser. So now parse result is an AST. Oh, actually, it's either an error message or an AST. So if it's an error, we print it, and if it's an actual parsed AST, it's always of the form that the top level thing is a par. That's just an invariant that I guaranteed in my parser. And so in that case, then we just print out the parsed AST, and then we print out the result of running my auto reduce function on it. So not too bad. We read it in a file, we parse it into an AST, we either print a parse error or the AST and the execution. Mm-hmm. So let's dig into the parser. Well, okay, here's one of my to-dos. I've got a bunch of these little parsers. Most of them are are pretty straightforward. And this is the one that parses a par. And one of the things that I'm going for here that's a little bit, tiny bit different than the R-chain co-op, not really in any significant way, is that I want to allow trailing and leading vertical bars, par bars, because a lot of times, like if I have, oh, well, that one's pretty, if I have a program that looks like this, you know, maybe this is a perfectly valid program, and then I want to do some editing, and I just delete this line or like comment out this line. Now I've got this trailing par up here, and I'd like that to still parse, even though I have that trailing par. So that's one of the things that I'm trying to achieve with my parser. So here it is. We look for filler. Filler is white space or comments. Then we have an optional bar. And then we parse all of these P's, and it's a do block, and so this is the do block. So let's see if I can read this. Holy crap! Parse sep end by 1. So okay, sep by is the basic one. Sep by means I want to parse a whole bunch of whatevers separated by a different whatever, right? So in this case, I want to parse a whole bunch of processes separated by vertical bars. The sep end by, the end, means I can also have the optional bar at the end. So it's like proc, and then at the end an optional bar. And the 1 means it's not 0 or more, but 1 or more. Okay, so I want to make sure I get at least one process here, optionally a bar at the end. So I manually encoded my optional leading par, then I'm using sep end by 1 to get the optional end one. So, okay, fine. So now that I've got that done, what is the thing that I'm actually parsing that's separated by these bars? Well, basically it's just a process, but I had to get a little roundabout here and say it could be white space and comments, and then a process, and then more white space and comments. And then finally, after all that said and done, there could be a little bit more white space and comments. And now finally, we return the par that contains all the processes.
And now the question is, can you have par separated by this? Because you're saying, I will have this parse proc separated by pipe.
Yeah.
But you didn't say that you can have par separated with the pipe.
That's right. I think that's what I want here. So parse proc is the thing that I'm doing separated by pipes, right? And that's here. And it tries out most of my different process parsers, but not a par. And I think the reason I did that is because I don't want them to be nested when they don't have to. I want it to stay as flat as it can. So like you wouldn't parse it as a par within a par within a par. It's just a flat list of processes.
Yeah. But when you're parsing, when you're parsing this your par parser, can it parse this what you are saying? I'm thinking. Yeah.
So I guess, one thing that I've been thinking about that I'd like to make simpler if possible is like, I've just written filler all over the place in here. And the only reason I haven't done it in all these other things is because I just haven't gotten to it yet. And they're incorrect because they don't accept white space and comments. So I was curious if there's a way to just be like, look, dude, I have this parser called filler. It can literally go in between any other parsers anywhere in the whole project.
Or you must specify it. Yeah.
Just like I'm doing here, just typing it over and over and over.
Yeah.
Okay.
But not in you can say for example, you could say that parse proc is with spaces. So in all other places, you don't have to specify it, because when I was trying to write a parser, this is not like for me. This is not just write it down, and I was spending a lot of time to just trying to figure out how will parse correctly.
Yeah,
Because
exactly.
If you put something optional and then you're trying to do this in recursion, it ends up or it cannot finish, or you don't get to what you want. Yeah.
So it sounds like my experience of spending more time fighting with the parser than actually reducing the expression is not that uncommon.
For me, not.
Okay. So where was parse proc? Somewhere. So you're saying maybe my filler stuff should go here in parse proc.
Yeah. I must look how I did it. So
yeah. Okay, let's look at that next. The thing, I don't think that's the total solution still though, because like if we look at this one, I still want to have filler here. I want to have filler here, here, and here. Like I should be able to this is for whatever, and that should still be able to parse. Yeah. Okay, cool. So I think
I'm defining this filler as two underscores, to look more like a space.
Yeah. Instead of calling it filler, you mean you're calling it? Yeah. That's a good idea. I don't think there's. Oh yeah, there is one more thing in here. Okay, so imagine. Let's get this back to how it started. This parse is fine. And if I like mess it up with invalid syntax, like that doesn't parse, which is good. I'm really happy about all that stuff. The problem is that still parses fine. If it ends with junk at the far right, it still parses fine. And so I felt like maybe there should be like an EOF parser or something, but I couldn't find that in the docs.
I think there is.
Oh, that would be great.
I just want to say, I think there is, but you can write it yourself easily.
Oh, and can you give me some quick advice or something?
I didn't implement it also because I was thinking I will do this later, but yeah.
Oh, you also did not do it yet? Yeah,
I did.
Oh, okay. Well, I wonder, like...
I was watching some examples, yeah. I think I seen EOF.
I definitely saw it in like forum posts and all over Stack Overflow, but I didn't see it in the Parsec docs and I couldn't make it work.
Maybe it's in definition of this predefined tokenizers.
Yeah, maybe.
Because I definitely want to use existing tokenizers,
Yeah.
For example, now I'm using Java style identifier because it's the same as in Roland.
Oh yeah, where do you get that stuff from?
It's a part of the parsec when you have these definitions. Token, I think it's called token. And the language. Yeah, here is the language definition. So you have all this. Sorry?
I looked at this a little bit. I think you had sent me at some point the language definition for Haskell itself.
Yeah, and you can say this is the record structure, but you define for my language. My comment starts with these characters. My block comment it's like this. My identifier starts with this symbol, and when you define this for your language, you can just say, okay, now generate my parsers.
Okay.
You don't have to do this all by yourself.
So most of this stuff makes sense, right? Like comment start end, line comment, nested comments. That's all straightforward. I could just do like /*, //, false. Exactly. Identifiers and operate. Oh, identifiers is totally fine too. Like I could use the Java one, like you said.
Yeah.
Operators though, like where would for go if I wanted to do the for comprehension, or like the arrow op? Would the arrow in the for comprehension be one of these?
No.
No.
This is too specific.
Oh yeah, okay. This is not a
what-
whole solution.
Yeah. This is like just for this for these things that you always have, like a comments or identifier.
Okay. So it's yeah. Of course, it's I should have known. It's not like you pop in a couple things here and it's magic. Like this gets you the basic common things so that you can focus on your language specific things.
Exactly.
Okay, cool. You use this?
I'm using for comments.
Okay. Oh, cool. Yeah, I'll take a look.
I imported the Java style definition, and I'm using comments and I think identifier. Or
So where did you find the Java style definition? That's like also comes with parser?
it's in here. Yeah, you can. I think it's if you go back and go to the language, maybe here a text parsing language, but I'm not sure is it in combinators or maybe this. Yeah.
Oh yeah.
There is some kind of Mondrian definition. I'm not sure what language is this.
Oh yeah, me either. Oh, what do I do here?
This programming language or sorry?
How do I I don't know exactly what I wanted to see when I clicked on this, but I thought it would at least tell me like what they used for like comment start and stuff like that.
So you have this, for example, Java style. This is like
There we go.
this is the record that this is the definition that we seen. Yeah, this record.
Identifier start letter. Yeah. Oh, it makes perfect sense.
This is like predefined records, nothing else.
Ah, okay.
And you can reuse the existing record and just put the difference, or you can create your own. And
That sounds like a good idea. Yeah. Okay. Cool. That's a lot.
yeah,
That's,
it has reserved names, which is also like a keywords.
yeah. That's great. That's gonna help me out a lot. All right. I think that's all my questions from the parser. So let me just make sure I didn't mess anything up there. Yeah, just comments. Okay, good. So row types. Let's see here. See if I can remember what the hell I was doing. Oh yeah. This is the main thing here. This is where I want to start to talk about it. So a process can be a par, which is parametric in a list of processes. And it has this type variable here. And the type variable is because I was thinking about doing something where the ground terms are defined a little bit separately. So we can like code up a basic row calc or, maybe something even a little bit more row-langy, but not building in the primitive types like the ints and strings at a level that confuses it with row calc, but where in reality, those are all just ground terms. They're all just nil terms. And then we have a separate language that can operate on the ground terms in terms of like integer arithmetic and string operations and stuff like that. I don't know if it's a fully baked idea yet, but it's just something I was trying.
Yeah, I didn't try like this because if you have this parametric, it's difficult to write.
What's difficult to write?
Everything else.
Oh.
Because
like for example, string concatenation.
No. I mean, you have this this is like a generic type. You must supply the other type for every other operation. You must have this parameter to every function.
Yeah, right. Oh, I see what you're saying. So that's right. So my plan was, at the moment, we're only doing actual row calc. I don't have any ground terms. So let's just put unit in there. And what we actually export is this thing. So we can just write proc without the prime and without the parameter, and it means proc of unit. And then later, like maybe it could be proc prime of primitive, where primitive is, whatever other data types I feel like putting in. Yeah, maybe it'll turn out that that's a bad idea and more of a pain than it's worth. But
I'm not saying it's a bad idea, because I would also like to have this kind of definition.
Yeah.
But I started without because I was thinking that it's much easier. But yeah. But I'm still not sure. I'm still not sure what is the what would I want to do with this parameter.
Well, the reason I ended up here, this is my attempt. This was the first time I felt like I maybe understood how to do something that I know how to do very easily in Java, which is, say, like there's a class called proc, or maybe it's an abstract class or something. And then there's other classes or abstract classes that extend it, like par and send and receive and ground. And then maybe ground is also an abstract class, and you can further extend it. And polymorphism is super easy because, like in Java, you can just have a list of procs, and that list of procs, because of that class hierarchy, it can include pars and sends and row strings and row ints all directly. And with Haskell, it's probably just because I'm a noob, but I don't know how to do that. I don't know how to make a list that contain for example. You
mean how you want to have a list of abstract types, and then you want to have different types in this list, because you have an abstract list.
Right. So like.
And in Haskell, you can how you encode this is with this sum type.
Subtype.
Sum type. I mean this data constructor with different options. But you don't have this inheritance chain.
Okay, so there's a word you're saying that I think is this sum type.
I'm saying SUM, sum.
Sum
like
type.
Like a product and sum, because sum type means choices.
Yeah.
Yeah, product is two types combined, and the sum is like a plus. It's
so this is like a one of versus like each of types or something.
Yeah, because your primitive data type is a sum type. It can be row string or row int.
Oh yeah, exactly. But we only get one level of doing that. That's okay. Let me see if I can.
In Haskell you don't have an inheritance chain. So
totally. So how the hell are you supposed to do something like that? I thought about using data like classes or something, like maybe proc should be a class instead of a data type or something.
Well, this is exactly the problem of expression problem.
Oh yeah.
Because in object-oriented language, you can easily make a new implementation of this abstract class, so you can extend the structure very easily.
Yeah, right.
But if you want to extend the function of on this structure, this is very difficult, because you must change all the implementations. And in Haskell is the other way around. You can very easily create new functions, but you can. It's very difficult to add new choice in the primitive.
Oh, that's true. I never realized it was a trade-off. I was so stuck in Java world that I was just always used to doing it that way.
Yeah, it's definitely a trade-off. It's a famous problem defined by Philip Wadler, expression problem.
Defined by what?
By Philip Wadler.
Okay, could I Google expression problem or what?
Yeah, definitely. Yeah.
Or that's
Philip Wadler with W. Wadler. Am I saying this correctly?
Oh, it's hard to. Oh, I should.
Yeah, exactly.
Right. Okay. Cool. All right. So nothing too interesting here. That's just the data type. So here's where I started to do some evaluation stuff. Okay, so the first function that I'll introduce you to is for substituting expressions. So like, you know, when you have a receive with a continuation on it, that continuation in general has some free names, and we need to substitute actual processes in for those free names. So the word peg came from when I was originally calling it like putting a peg into a hole, but I'm not using the word hole anymore. I'm just talking about free names. So basically target, this is like the continuation. Binder is like whatever, it's a string, whatever free name I'm trying to replace. And then peg is the thing that I'm trying to replace the free name with. So we just go through each one of the possible types of a process. So like if it's a nil, then no problem. We don't have to, no substitutions happen. If it's a send, well, then we're still going to get a send, but we need to recursively make the substitution in each of the two processes that a send is parametric in. Oh, I forgot to tell you guys something really important. I think I told Isaac. There are no names in my row calculus here. So there's no quote operator. Maybe we should go back to row types, because that's actually important. Like you might have expected to see a D quote somewhere in here, and it's not there. And you might have expected to see something like data name, and its only thing was quote proc or something, and that's not here either. And so the idea is saying that the names are quotes of the processes is the same as just saying that the names are the processes, and then we don't need that whole extra data type. So that's the model that I'm working with.
This is very interesting.
So yeah, oh thanks. Isaac was calling it the procalc with a P for processes.
Yeah, so one way that Greg has said it, and I think other people have said it, is if you look at the names, they're isomorphic to the processes, just in the sense that they're in, you know, one-to-one correspondence. You can have some preservation of properties or whatever. But from what it looks like, the names are helpful. I just can't figure out why they're helpful, especially because the names really are just processes anyways. So yeah, I'm still a little bit stuck on that.
Yeah, I'm thinking that you want to know when, for example, I don't have like an exact situation, but I'm thinking that how did you know when you're sending the process to you know, different node on different network? You must have the point when you will synchronize, when you will serialize the process and put it in in something different, that you can say, okay, I serialize the process, and now it's not the process, it's something else, you know?
Yeah. So what do you mean by serializing the process, first of all?
Yeah, well, I'm not sure if this is necessary for the calculus or this is necessary for the real world.
It's definitely necessary for the blockchain, and it's necessary for like saving stuff to disk. But I was thinking serializing is something that we've done for a really long time, right? Like there's libraries for it out there, and it doesn't require us to wrap our process in another tag in order to then serialize it.
Yeah, but in Rolling we have a reflection. So reflection is a first-class citizen in this language. So because it's first class, I think that we need some kind of way to differentiate these two states that process can.
Okay, well, I'm going to keep going this way and see if I ever get stuck.
But I'm interested to see how this goes in your example.
My experience so far is that when I had the quotes in there, which is how I started, it was always just more of a pain in the ass to keep quoting and dequoting. And that's also my experience as a Rowline programmer. You know, you spend 20 minutes writing your code, 10 minutes doing normal debugging, and 10 more minutes getting your stars and ats right. So I'm hoping to solve that problem. And so far, so good. We know that the first thing in the send is the channel that you're sending over, just because of its position, right? Or like in the syntax, because it. So actually, let's look at this again. Where's my send parser? Right here. So the way that I'm parsing a send. Oh, I actually didn't do this the way I meant to. Oh man, I think I got myself a little confused at some point here because it looks like this isn't the version I thought it was.
And what did you want?
Oh, here's how I did it. Yeah, here's how I did it. Okay, I remember. So here's what parse chan looks like now. There's a literal at character that's only syntax, and then it's a process, and it just returns the same process that a regular old parse proc would have returned.
I'm not sure. Yours. What does it mean to chan? You're parsing chan.
So
you mean that you have only the name. You're not specifying send or anything. You're just putting the name. Or
yeah. So let me show you where I used it. Here's parse send. First of all, we parse a channel. And so remember, that just means we parse an @ sign and then a process. So C is a process. It's also a channel because I'm sending something over it. Then we parse an exclamation point. It's part of the syntax, just like the @ sign was part of the syntax. And then we parse the process that we're sending.
So my question is, why do you need at?
You don't. No, you definitely don't need at. It's there as part of the syntax, just so it looks like Rolang.
Okay, this makes sense. Okay.
Yeah, good question. Okay, so let's see. For receives are similar, right? We're going to recursively do the substitution on the channel and on the continuation, and the binder was just a string, so it just comes through the same as it was. Now, free names, this is the interesting part, right? Free names is where it actually, we actually do some substitution. So if we got a free name of F, and F happens to be the same binder that we're actually trying to replace, then replace it with this peg, and otherwise it's some other free name, so just leave it untouched. And then, likewise with pars, we're just recursively subbing into every single element in the list of parred processes. So
you have a tuple space.
Yeah, okay, so there's two different evaluation strategies here, and I've only coded one of them so far. This is what you were maybe hoping to see tuple space-wise. So a tuple space is a pair, right? It's a two tuple, and the two things in the pair are a map from channels to processes and another map from channels to processes, and the first one is the sends, and the second one is the receives. So the tuple space is basically like a bunch of things being sent and a bunch of things being received, and so those are represented as two different maps.
And this is all you need.
You don't have to
store, yeah. You don't have to store anything else, right?
I don't think so.
Oh, nice.
Yeah, I'm not totally sure that this is the best way to go, but it's what I've done so far. And this is for the one that I'm calling auto reduce. And auto reduce is when you just want a reduction and you don't care to see all of them and you don't care which of the possible reductions you get. And that'll probably be useful in cases where there is actually no non-determinism, right? Where there's only one valid reduction. So here's how auto reduce works. So basically auto reduce prime does all of the interesting work, and then auto reduce is the one you call. So like auto reduce is basically like a recursive helper function. So it takes in the current state of the tuple space, the current state of the executing process pool, and then it's going to give us back either a string or the final tuple space. Let's see if I can remember why it was either string. Oh, yeah. String is for error messages, like there was a top level free name, for example. So basically, like when everything works correctly, auto reduce just gives us back the final quiescent tuple space. So wow, I wonder if I can read this. So if we're auto-reducing some tuple space and the process pool is empty, that's our terminating case, right? There's no more processes to reduce. Everything's jammed into the tuple space. We're done. Just return it. In the more general case, we're going to get the tuple space as a map of sends and a map of receives. And then we're going to get some process pool. And I've spelled it like this, where P is the head and ool is the rest of it.
Nice.
Yeah, yeah, thanks.
I didn't see this before, but yeah, cool.
So if the process from the pool that we're handling, now we've got to match it against all of these different possibilities. And that's it. So we'll just handle like each case of here's the thing that was the next process that we were going to process. And so like nil is super easy. It was just a do nothing process. So just throw it away. We're going to recurse with the exact same tuple space we had and the remaining process pool. Like that nil did nothing. If it turned out that what we had was the par, then we're going to just do some flattening here. So again, we're not modifying the tuple space at all. We're passing it through just like we did. But now we're taking all of these things that were inside the par and just concatenating them with the process pool that we already started with. So we're pulling them out of this nesting and putting them straight into the main process pool. If we get a free name, we've got a problem. So fail hard. There shouldn't be any free names in something that we're actually trying to execute.
Yeah, on the top level.
Yeah, that's right. On the top level. That's right. And so, and I made this to do scan AST for free names first, and maybe I'll still do something there, but I did make a function that tells me all of the unbound names in any process, all the free names in any process. Okay, so send and receive are the interesting ones, right? Send and receive are the actual like rocalc do something that I care about terms. And so in this case, we've got a send from the process pool. So we're working on this send. And what we need to do is we need to look up and see if there's any receives already in the tuple space that it can com with. And so we do this lookup. And if it turns out that we did get a receive that comms with this thing, in general, what we're going to get back here is a whole list of receives that could com with it. So we're just taking the first one. And then we're going to recurse. We're going to continue doing our auto reducer. The tuple space will have the receive removed from it. That's what prune tuple space does. And the remaining process pool is going to be, well, whatever was still in there. That's the colon ool. And this continuation of the receive that we just yanked out of the tuple space subbed in with, the message that we sent. So we're going to substitute the message for the free names in the continuation of the receive that we pulled out of the tuple space. And otherwise, if there was no receive that send could com within the tuple space, then we're just going to go ahead and throw that send into the tuple space and keep going. And then likewise for receive, we're gonna look up and see if there are any sends that can com with it. If there are, then we're going to take that send out of the tuple space and put this new substitution into the process pool. And otherwise, there were no sends that receive could come with. And so we're just going to throw the receive into the tuple space and continue.
Yeah, this totally makes sense.
So that's my auto reducer, and it works so far. It works.
I only have one thing. So you're doing this. You're matching send and receive in each of these send receive cases. But if you look, you can do this when you're constructing par. Because you will have
constructing par over in the parser.
No. Here, for example, because in the par you will have two processes, and you can very easily just say, are they matched?
So when you're constructing par, so you're talking about line 51?
Yeah.
So this is like when I pulled something out of the process pool and it happened to itself be a par.
But you don't have to, you could just say, okay, when par is happening, I will not combine these two things without looking if I have something to match, something to reduce. If you do this on that place, you don't have to do it anywhere else. Because par is the really the point where you do the reduction. This is like a reduction place. Or
Oh, okay. So I guess I'm considering the process pool the reduction place.
But the par is, as Greg is saying, this is this is monoidal operation in the row calculus. When you're doing when you're combining two processes together.
Monoidal operation in the row calculus. So
because
the operator is the par operator. The set is the set of all processes.
Yeah, and this is the same as Greg is telling for Arabic numerals. Plus will this is binary operation, and you will get two processes and combine it in one.
Right.
This will be if you cannot reduce it. This will be the return process will be par. But if you can reduce it, it will be result of received process.
Ah, you're thinking of par as a binary operator, and that's not how I've modeled it here, though.
Yeah.
That's the difference. My par is a list of processes, not a binary.
Yeah. It's okay because you're collecting, but when you can, this is what you are doing in send and receive case. You can do it in par. And in send receive, you can just collect it.
Okay.
Because you cannot have you cannot have reduction with.
What was that? Oh, you with us, Tomislav?
Oh, my connection is. Well, I'm saying that you cannot write any rolling that doesn't use par, and that will reduce.
That's right. Yeah, that's right. That's true.
So if you do the reduction in a par case, that's it. You're done.
Okay, but I'm not totally sure what you're saying. Like, it sounds like what you're proposing is like an O of n squared algorithm instead of this one, where like I get in, instead of using process pool here, I just take a process, and then if it's a par, if it's anything other than a par, I just say like error, this doesn't reduce. And if it is a par, or it doesn't have to be error, I can just give back the exact same thing I got. And then if it is a par, I look at the first thing and say, does it come with any of the other n-1 things? And if the answer is no, I look at the second thing and say, does it come with any of the other n-2 things? Does that sound right?
Yeah, but completely. But I don't know how exactly. I'm coming back to your first question. We have the whole tuple space with rolling terms, and you're writing a new rolling term to this set of processes, and so we need to match. We need to try to find. We need to search the whole tuple space.
Yeah, that's right. But it's a fast search because the tuple space is structured as a tree map. So it's an O of log n search through the tuple space instead of O of n through the rest of the par. Right? Because I can since the processes are keyed by what channel they're on when they're in the tuple space, I can go right to that channel and then grab the corresponding, like, other send or receive, whichever one I'm looking for.
Yeah, I see. Yeah, this is like a key value store.
Yeah, exactly. Yeah, I had used map.map wherever I did that up here. Yeah. So it's a map from what channel you're sending on to all the things that were sent. And then it's a map from what channel you're receiving on to all of the receives, but basically continuation free name pairs. So, okay, so I'm with you now. I totally see what you're saying. And so, like I was saying earlier, I think I have two different reduction strategies. And so this was the first one I coded because to me, it was the more intuitive one. And I think it might be the better time complexity one. But here's what it totally eliminates as a possibility. This thing is going to greedily reduce as soon as I get, when I get a send, if there's already a receive in there in the tuple space that it could reduce with, it's going to do that reduction as early as possible. It's going to prevent things from ever going to the tuple space if it's possible.
Mm-hmm.
But what that doesn't allow is nice debugging tools and interacting with your programs to check out the various ways they can reduce. And so the second one that I hope to implement is, I think maybe more what you were describing, where I get in a process pool and I just go through and weed out all of the nils and flatten out all of the pars and that kind of stuff. And then I say okay, pairwise, what can reduce with what? And then that's a great way, in my opinion, to introduce a debugger for a language like Rolang. Because, a lot of times you like to step through your code in an imperative language or step into a function call or something. So here it basically could be here's all of the eligible reductions. Which one would you like to reduce? And you select one. And then here's the next tuple space and all of the eligible reductions and things like that.
Yeah, when I'm thinking about something like that, I'm thinking that I would like to have different implementation.
Yeah.
Not one implementation to do both of these things, but different implementation, different part of the code.
Because debugging from the regular
event. To keep reductions and not reduce immediately. Because Greg was telling that he liked to, for example, for syntax erasure, for if you have nil par, if you have nil par something, it's something. And he was saying that he liked to eliminate as soon as possible these kind of things. Yeah. So in that sense, I'm thinking to for when I will start writing reduction, I will go in this direction. I will try to eliminate everything as soon as possible. But what you are saying it also makes sense.
Yeah. Okay, so, cool. Well, I'm excited to see how yours works out too. The comments here are basically explaining that two different reduction strategies. Free names, it's not too fancy. It's a simple recursive algorithm that for most of these processes okay, what are the free names in a free name? Well, that's easy. It's just the single free name. What are the free names in nil? There are none. What are the free names in par? We'll just look through all the terms in a par and concatenate, etc. Nothing too fancy there. And that's all of my reducer, or my, evaluator, I guess. So, Tomislav, the last really practical question that I have for you that's been driving me insane, I can't figure out how to run my unit tests, and it's discouraging me from writing unit tests, which I'm usually pretty good about.
I'm sorry, I seen it, but I didn't have time to check it.
Oh, okay. Have you done unit tests in Haskell?
No, really. But I have this repository advent of code, and there is I think I had some. I think I'm displaying results with tests.
Oh wow! Okay,
so
I can check out that.
Maybe you can check out, and I wanted to see to see what is the problem, but I didn't have time.
Okay, cool. All right,
I know that I'm using testing, but I didn't wrote anything special. I'm just using the initial template or something. Nothing special.
Yeah. One of the good habits I have as a programmer, one of the few, or I don't know, is being pretty good about unit testing. And since I'm not writing them now, I fear a future time when I'm going to be so backlogged with stuff that doesn't work that I thought worked, that I'll just be like, F it, I'm done with this project.
That's amazing.
All right, cool. Thanks for looking over that. I appreciate all the comments. Oh, Gary posted a link to the expression problem. Nice.
Should I load my
Oh, I'd love to see it. Yeah.
sample? Let me.
What's up, Gary?
Hey, I'm trying to follow Greg on the our music call as well. Sorry, I was watching the screen, but listening to Greg.
Nice.
Cool.
Are we waiting for Jim now?
Thomas Lav is going to show his Haskell code.
Good.
I'll make it bigger. Oh, I must turn on the light here. Sorry.
Yeah, no problem. You slowly faded out into darkness.
I think I can open all of these files in the same window.
Nice.
So here is everything visible, I hope. Yeah, this is just a empty record. Yeah. So from the last time I extended as I seen Isaac implementation in K framework. So yeah, I added like this ground names really, because I think it's the same if you encode the ground names as processes or names. But yeah, I don't have like a strong opinion, but it seems like.
Yeah.
And also I differentiate the process variable old name variable. Also, as Isaac was showing in K framework. And then this is why I have the bound name and bound process and variable process and variable name, and also depends on the place. What are you? Are you like quoting or not? You can have the ground process or the ground name. This is just that I want to keep information exactly. Are you using the name or the process?
Yeah.
You know,
yeah. I get it. The comments make sense totally. Yeah.
Okay. Because you can replace it, right, and just forget and do it all the time in the same way. But if you want to print it, you probably want to keep this information from syntax.
Yeah.
This is why I have this specific.
Yeah. Good thinking.
So Yeah, and yeah, my process structure. This is like the important thing.
So
I'm
this is
using
a record. So there's only one kind of process.
yeah I'm using a structure that Jake was written in Scala, and I found but he's using multi-set for each of the constructs, which I found that is not really necessary because only par is a set. I mean multi-set because you can have the same process multiple times.
Yeah.
But in all other cases, you really don't need to you don't need to have multi-set. You are like in your example, you are using the simple data type, sum type, right?
Yeah. This is a product type. It looks like, right?
Yeah, but I'm using maybe and if you look at how this record is used. It's enough to have the data type that have like a specific case, like your example.
Yeah.
So my next version will be with just a regular data type which for each case.
Oh, interesting.
Because,
okay.
Because I don't need height.
Well, that's what I was going to ask. Yeah.
Also.
What is the height? Looks like a good reason to do it this way. What is the height?
Yeah, height is just a number of nesting.
Okay. How many continuations deep it is?
Yeah, because Jake, in his example, uses height to generate bound names for substitution. But I will show that substitution you don't need to have you don't need to store this height in your data type in your structure. This is because each of this is maybe because for each construction here, I'm constructing just this record in just this field in the record, and all the other fields are nothing.
Input. Okay. So hold on. I don't know if I know what the Haskell syntax here means. Go ahead.
I'm filling. I'm creating for each for each parsing term. I'm just filling this structure. This is the same as you are doing in your example. It's the same.
Well, on the left side though, you're making process an instance of process semantics, right?
Yeah.
Where's the class process semantics?
Process
it's
semantics.
On the top right. I see it. Okay.
Yeah. This is like the final encoding, and this data structure is initial encoding. This is like the real structure.
The class process semantics is your final encoding?
Yeah.
Okay, so anything that is a member of the class process semantics has to implement 5 functions, right?
Yep.
Okay, I see. And then what are those? Okay, so it looks like those functions are named pretty close to being a fact that those are named after the different kinds of processes you can have in the row calc. What's eval though?
Exactly. Sorry. Oh, eval is a dereference. It's a star.
Oh, okay. Oh, yeah, the comments.
And also here I call it array file because name.
They can't. Yeah. Oh, that's why they're all called slightly different. Yeah, that totally makes sense. Okay. I wondered why it was 4 here and it was input there. That totally makes sense.
Yeah.
Okay. So. But why are these all functions? Like, what does the nil or stop? What's the function nil supposed to do when I call it on a par?
Nil function is this nil, you mean?
Yeah.
Well, this is this is really a constructor. I mean, this function doesn't accept any arguments.
Right.
So you can just say this is nil, and this is nil construction. And when I parse nil, I will just create empty process. This one here, where all the inputs and outputs and the evals or drops or pars, everything is empty.
All right.
So this implementation, it's really just how to combine this final encoding and initial, because a parser will create and call all of these functions. You know, and if you look, all of this construction except par are just put what they have in the structure. So for inputs, they're filling input field, fill output field, and all the other stuff are nothing. And in the par, I'm doing the same thing as you. I'm combining these two processes, and I'm thinking that in this place, I want to add reduction, because here I have exactly two processes that I want to compare.
Yeah, right.
But yeah, but I'm thinking that I also need to compare. Yeah, I have two multisets. I must compare it and see. Yeah, for each of them, are they equal?
So
are they can reduce.
That dot bar function,
yeah,
takes in two processes, P and Q, or takes in two of something. I'm not totally sure what.
Yeah. This is a process.
Oh yeah, right. Because process is what's being the instance of.
Yeah, here what it's here the process is what here is a P.
Yeah, right. Okay, I'm with you. So it seems like it's taking in two, but then on the bottom right on line 12, it looks like a par is more similar to what I did, where it's not a binary thing. I mean, you did a multi-set, which is probably smarter,
exactly.
And I did a list, but
it's the same.
A lot different than being a thing that takes in exactly two processes.
Exactly, and this is the place where when you implement this. So yeah, this is the part of structural equivalence.
Yeah.
Because when you put nil and nil here,
yeah, it
will create multiset from nil and nil, which will result only one nil in this multiset.
Oh, really?
Well, not. I'm not saying correctly.
I think if it were a set, it would only be one nil, but a multi-set probably would be both, right?
Yeah. Because this kind of erasure will not happen here, but with multi-set, your multi-set will give you what will multi-set forget? Because
order.
Yeah, exactly, order.
Yeah.
So this is what Greg was explaining about collection of terms.
Ah, okay.
Because we have final encoding with all the terms, and we are transferring this to the initial structure, which will forget something.
Yeah. Okay. Yeah, that makes sense.
And for example, this kind of construction will reduce to only P. If we the reference something is quoted, it's really the process itself.
Yeah. Yeah. Cool. So does it? So does it reduce?
No, I don't have reduction still.
Okay. Oh,
Yeah.
wow. So you have final and initial encoding already before. I thought final encoding, I don't think I understand final and initial encoding. I got to do a little more research on that, I guess.
Yeah, it's just a matter of how you express your construction. In initial encoding, you have well, I don't know explanation. What is how I say official explanation, but
Yeah.
in initial encoding you have structure, and in final encoding you have functions.
You have functions.
Because final encoding must you are modifying the different parts of. No, I'm not sure how to explain.
Okay, yeah, that's okay. I mean, I can. I need to look it up on my own too.
Because I'm not sure how to explain it in relation to Haskell implementation. This is what I'm struggling to.
Yeah.
I'm familiar to this stuff through Haskell, so like I would like to hear like a better explanation because I have a question. Is this related to category theory between different kinds of adjunction between categories? This is what I would like to know. Maybe we can call Christian to explain this to us.
Yeah, he sounds like the right guy for sure.
Because he was explaining this this stuff already, but then I didn't know most of this. So yeah.
Yeah, cool. Good. Okay, so when you do get to write your like reducer, is it going to operate on the final or initial encoding? Final, right?
No, only on initial.
On initial, okay.
Because with final encoding, you don't have to specify how you're collecting stuff. You're just saying, okay, this is my language. You know, I have these functions. But when you want to optimize, you must put this in some kind of concrete structure that you can compare. This is, in this case, multi-set or some kind of record when you collect things, and then you can do optimizations. Because there is a relation to fusion, because you can implement some language with directly in the initial implementation, but then you are immediately on the lowest level. This is why you want to have this final implementation to be more abstract.
Okay, all right. So is the evaluator the thing that takes you from initial to final encoding?
This implementation, this instance, is really a way to go from the final to initial.
From final to initial, or from initial to final?
From final to initial.
Oh my goodness! Even the name ordering doesn't make sense.
But the names initial and final is not related to initial and final as a, you know.
Like Ty, had nothing to do with we start at the initial part and end at the final part.
No, it's related to. I'm not sure correctly. I'm not sure exactly. Yeah, but it's not related to. This is like a before. Initial is before final or something. Yeah, it's not related to that.
Okay, all right. That is very good to know.
But I can send some links about category theory where I learned a lot, and maybe I would like to hear what Christian would say about that.
Yeah, that would be so cool. I wonder if we could convince him to do that.
Yeah.
Okay, cool. Are there other parts you want to show us here?
Yeah, I want to show substitution.
Oh, yeah, great. Okay.
With substitution, I'm using, let me see, I think I'm using height. Oh, substitution is just, yeah, substitution is just a recursive call. And yeah, it's just going through to this for each construction replaces just is the same as in your example. If the name is the same, because we are replacing names inside the process, not the process itself. So if the name is the same, we will replace it with the name that.
Yeah, right.
Yeah, and recursively do this with the process.
What is I? What, like the very first character on line 54 is I. What does that mean?
It's just the name of the function.
Oh.
I as an input, O and D.
Okay.
Yeah, not not the best.
No, that's okay. I totally get it now. I just wasn't sure what it was. That makes sense.
And here, because I'm encoding ground, because I'm encoding process variables as encoded as reified process variable, I'm deleting this. So if I have a quoted reified process variable, this is exactly the same as process variable.
Gotcha.
And I'm thinking that in the same way, if I'm using process to encode names variable, this will be like the other way around, right?
Yeah.
So this is why I'm thinking it's the same how you encode the names. But what you are doing with to have a structure that is parametric in this, that will be good to see. Is this
whether it works out or whether we realize in 2 weeks that it's necessary to keep the names.
Yeah, but I'm thinking that if you're parametric for ground processes.
Oh.
This is what I'm talking about. I'm not sure. Is it possible, or is it a good way, or I'm not sure.
I don't know either. At a high level of abstraction, it seems like a really good idea, because my thought was like, it would be really nice to be able to use this row calculus model to model like our interactions between, row calc processes, where that's the best way to go, because in a lot of cases it is. But then like import whatever level of richness of ground terms you want. So like maybe I only need integers and addition in my ground terms, and that's it. Then I don't have to worry about all that stuff about tuples and maps and strings and all of that stuff. And then in other cases, I might want to do something really complex and have like, a whole functional language imported within my ground terms. But yeah, we're a long ways off from that. But that was my thought at a high level.
I'm not sure if you are parametric in your like a host language, when you write in language in which you are writing your interpreter. I'm not sure if you're keeping this parametric. Can you write the code? Because
I don't know.
You're generating, you're creating a name which you want to represent differently in your host language.
Which one's the host language?
The language in which you're writing your code.
Haskell or Rolang or whatever thing is the
Haskell.
ground terms.
In this
Okay,
case,
got it.
in this case, Haskell. Yeah.
Yeah.
So
Yeah.
but yeah, I would like to try it and see it. Yeah.
Yeah, cool. Yeah, okay.
Mm.
So I think I see how substituting is pretty similar. It just looks a ton different. Like, is there pattern? Oh, there is pattern matching there. So what does the I function do again? I know it's just an alias for, input equals I input. Yeah. So what is input then?
Oh, you mean I'm here. I'm just creating this one maybe.
What does line on the left side? What does line 47 do? For example, or 48 or 49.
47.
Yeah.
Oh, I'm creating the record from empty process. I'm filling these fields.
So, what is input? Where was that? I guess.
So I'm using wildcard record wildcards.
Okay.
And
this is like a GHC extension. Yeah. Oh, you sent me that link. Yeah, I remember.
Yeah. So when you do this, it's the same as you deconstruct all of the fields manually.
Got it. Okay. That's right. Makes total sense.
Yeah.
I'm with you. Okay, so you're taking you're on line 47, you're like taking whatever input you got, pumping it through that I function or something. Is I a function, I guess?
Yeah.
Where did it get defined?
Sorry?
Where did I get defined?
This is the definition of I.
That's the definition of I.
Exactly.
Oh, where? Yeah, where is so tricky to me. Okay, yeah.
Yeah. And I'm just pattern matching here. And I'm saying, okay,
now that I can parse the Haskell, I finally understand what's happening. It makes perfect. It's almost identical.
Yeah.
Okay, cool. So where's the one you did where you did par? Because that's the one where we thought maybe we weren't going to do it the same way.
The par is here. I'm just
that one's just right up there.
Yeah, I'm mapping.
Yeah, it's a map. Totally. Okay. Yeah, great. I can read it now. That's great. Okay.
Yeah. But here in this place, I'm thinking. Well, not in this place, but yeah. But I'm thinking where I can put a reduction. Yeah, this is what I'm thinking.
Yeah. Okay. The reduction.
And I can generate free names.
Cool.
Let me see. I'm using height.
This is a proof we don't need to store height.
But I first want to see where I'm using height. Yeah, when I'm generating the structure, I'm using height to generate these bound names. So this substitution, I'm not. For this substitution, what I'm supplying is bound name 1, bound name 2 for each nesting, and of course I'm using height to keep the track. But when you see this code for free names, this can be a parameter to the function.
Mm-hmm.
You can just say free names from 0, and then you just increment for when you have input, you just increment this number, and that's it. You have increment. You have one. You have increment for each nesting.
So I see at the bottom you're saying replace free variable with unforgeable name. So unforgeables are in here?
Yeah. This is like the next step, because if I have top now I want to implement new.
I was thinking new might be my next step too after I implement the other evaluation strategy.
And what I want to do, when I implement new, I can replace all the free names, right? If you have free name that is not bound, this is like a syntax error. But if you put new around it, it's okay. Right?
Yeah. Oh, yeah. Oh, I see. Yeah. I see what you're doing.
I can show you quickly.
Oh, I'm glad we're talking about this. I'm not there yet, but I've been kicking around how to maybe implement new.
I'm not sure yet, but not new.
I've never gotten new REPL to work for me. I love how you do that, but I can't make it happen.
I will say like this. Yeah, okay. So I can say something like this. And also I have pretty printer with indentation. So
awesome. That looks great.
So I'm just replacing this about name in here, in nesting. And for now, if I have something that is not defined, it will just stay not defined. But if I need a REPL. I cannot call Haskell function from here, of course. Because I want to call free names on the result.
Yeah.
To syntax. Yeah. And I can use just send and it's okay. I think I can call it this or free names. I must input semantics. I'm just guessing.
Oh, is it the 42?
Yeah.
Oh.
So I'm just replacing with the ground term, with the unforgeable name.
And you replace the word send with an unforgeable name.
Yeah. Because
yeah. Oh, cool. Okay.
And what I will do next, I will just say, okay, new send, and that's it. I will generate unforgeable name for send and substitute it inside for each case.
Yeah.
And that's it.
That's great. That's a great idea.
Very so this is where I stopped.
I'm glad you showed me that. That gets me a lot of thinking about how to do new. Cool.
Because I was not sure how to implement new. What is new?
Yeah.
But new is just a collection of names that you are saying. I know these names. You know, it's not unknown names.
Right. Yeah. Something that looks like it's free, but I'm like, dude, I don't make it free. I want to use it.
Yeah. It's like a private name. Yeah.
Hey, Tomislav, that's really interesting, man, because that's exactly how I was going to implement new in K framework.
Oh, cool.
Yeah, like exactly the same thing. And then I was just going to like generate a, unforgeable of like a fresh integer or something every time I replace a name. But I mean, presumably you could make the like integer for the unforgeable name, just, you know, link it with like a hash function or something, or like whatever it is you need to do, you know?
Yeah, I'm just saying whatever it is. I will just generate with a incremental integer. But yeah, I must put everything here in a for, so I can get you know, nesting.
Yeah.
This B will be first, and this inner this is 0, and this is the first.
Yeah.
Because these are two unknown names.
Yeah.
And this is almost the same as bound name. No, it's just counting.
Right. Yeah, that's cool.
Oh, X0 is totally different though. X0 is not an unforgeable name.
No.
It's going to be bound to whatever comes in on B.
Oh yeah. X0 is still like your De Bruijn index or whatever, right?
Yeah, exactly. But now that I wrote this, it's the same. It's just a different number.
Right. Well, yeah. Like unforgeable doesn't mean anything yet.
Yeah. It's like a different set of names. This is like a private names, unforgeable, and this is bound names.
Mm-hmm. Cool.
Yeah, interesting.
Should we wrap it there for today?
Yeah. I don't have anything else. So yeah.
Isaac,
I just want to say
anything from your K work or anything else?
Oh man, I could show one thing that I thought was really weird that I had to do. It was like using one of the K functions.
Yeah, let's do it.
Yeah, I'll show screen real quick. Yeah, I've like sort of been working on some stuff in the background. I'm really aggravated with this thing. It's not working right now, but you know, hopefully it'll work someday. So what are we looking for?
Isaac, your examples for ground terms are very helpful for my implementation.
Oh, that's great to hear, man.
Totally.
That's good. And that's how. Actually, since we're talking about it, I can show you real quick. That's how, well, maybe not, but that's how Derek was doing it as well. He had like the unforgeable names as ground terms, and yeah, that like and
yeah, on the link you're sent, right? His implementation in K framework.
Yeah, exactly. Yep.
Yeah, I was looking at that, and he was adding ground terms to process, and I was in my implementation. There are names, so yeah. Oh. I think it's been done in both ways.
All right, cool, man. So the thing I wanted to show you guys. So I showed you the structural types that I had for RowCalc last time. So I'm currently working on something that takes one of those expanded binary trees for the structural type and basically recollapses it into the process or where it is that it came from. And I'm currently having issues with it. I know where it's getting stuck, but I'm not sure why it's getting stuck. But nonetheless, kind of as like a side thing, I wrote this program that will like tell me the depth of one of these structural types. So basically just like what's the longest branch in this binary tree.
Oh, and, yeah.
Yeah, so basically all I did was like, define this function, which I called like, hashtag depth. It takes in one of those structural types. It gives me an integer. Also additionally two leaf type to just like further differentiate my kinds of types. So there's three main kinds of types that I'm working with. So there's initial types, which are basically like, just like, you literally write the word type and then you put your process or your pattern or whatever it is you want it to turn into the structural type. So that first thing that it takes in is the initial type. You want it to expand into this long thing, and that long expanded version is the terminal type. And then there's like an intermediate version of the binary tree, which you call an intermediate type. And it's just like some parts have been expanded, but maybe not all of the parts have been expanded. And so this is kind of like one of these intermediate types. But basically the whole point of that structural type function is that it just like takes one of these initial types and rewrites all of it into a terminal type. And so with this untyping thing that I'm working on, I figured I should just be able to do exactly the same thing, but in the opposite order, like start at the leaves and basically like collapse them and then just keep going up. But it keeps getting stuck in the same place. But either way, so these terminal types basically come in two flavors. One of them is this leaf type that I'm defining here, which is basically like exactly what you would think as, well, a leaf for a binary tree. And by a leaf, I mean like you're at like a terminal, you know, node in the graph or whatever. And we're talking about like the two that kind of branch from this terminal node. But either way, so
when you say terminal type, you mean when you wrote directly integer, string?
Yeah, exactly. Yep.
Okay.
Yeah. So either way, this function, like I said, basically just tells me the depth of one of these structural types. And so, I mean, it does the type of thing that you would expect. Like if you give it a leaf, so just like one of these like, you know, final looking things, it's basically just like, for example, it'll be like leaf integer 1, you know, something like that. If you were, I don't know, sending one on a particular channel or something. But either way,
when you say leaf integer 1, in surface syntax, this is, you're using and, a and 1 in a pattern, or
wait, sorry, what?
Like when you're matching in a pattern, you're saying a, my variable, and integer, or no, you're saying 1 and integer, or.
Well,
what are you looking at, Tomislav?
Yeah, sorry, you're looking at 39 right here.
Well, I'm trying to figure out when you're saying. How did you say? Did you say and 1 integer and 1?
So check out my definition of a leaf type right here. So basically, it's you literally see the word type, and then in these braces, right, you have just a string and then two things that I'm calling leaves. And examples of leaves are like the string nil and, you know, like nil. So like when I'm parsing something like, or when I'm turning a process like nil into one of these structural types, the way that it will come out is it'll be type. It's a leaf. So it'll be the string leaf here, and then it'll just be the string nil, and then another string nil capitalized this time. But either way, it doesn't really matter. So either way, there's basically like a graph with 3 vertices. It's a binary tree. The top one is leaf. The bottom left one is like nil, and the bottom right one is another nil.
But I'm not sure that I understand structural type. What do you mean by structural type?
Yeah, so structural type was the stuff that I was showing you last time. So basically, if you have like 2 process variables in parallel or something like that, it'll take that pattern and it'll say, this is a par of 2 things. Those 2 things, the first one is going to be, a process variable, and the second one is also going to be a process variable. So it'll just be like a binary tree.
And you mentioned pattern. This is possible only in pattern. I'm just
but a concrete process can be a pattern.
Concrete process.
Yeah, so concrete process is just a pattern that has one thing that matches it, basically, and it is that pattern.
It only matches itself.
Yeah, it only matches itself, exactly. I mean, it's silly, but it's like, you know, a pattern with no variables, basically.
Yeah, I mean, it makes sense. Like, you could be trying to pattern match like an addition expression, and you want a pattern match on like a plus 5, and then that match is like, you know, 6 plus 5, and a gets bound to 6. But then as part of your submatching, the 5 had to match the 5. That was a concrete process that was used as a pattern, I think.
Okay. So you're saying, well, I have a question. Where we can use types, because in a sense I don't understand what is string in Erlang. When you write string, is this a process?
Yeah. So a string is a process. Yeah, and in fact, it's a ground process.
Oh, wait, hold on. This is related to Rolang?
What's up?
This is related to Rolang?
Well, I mean, this is for, so yeah, it's related to Rolang because it's like, you know, row calculus with some ground terms in it. And the ground terms that it has are, you know, integers, booleans, and strings.
Oh, okay. I thought we were just doing like generic binary tree stuff. So there's like processes and stuff in here?
Yeah, this is exactly the stuff that that Derek had written up. That you and I talked about it. It was a while ago, but
yeah, I remember when we did the like pattern matching stuff on the whiteboard.
Yeah, exactly.
Okay, all right.
That's exactly this. Yeah.
Okay.
Yeah, so this is for pattern matching. I'm sorry, is that what you were asking?
Yeah. Patterns in pattern matching.
Yeah, exactly. Yep.
But you are saying that I can send or receive on a string, but the string as a type. But quoted, because it's a process. So if I quote it, can I send something on string?
So you're saying like is at the string 1 like a valid channel name?
Yeah, at string, is it valid name?
I mean, I have been treating it as if it is. I'm pretty sure it is.
Ah, cool.
If string is a ground term, then that string is a channel. Yeah, definitely.
Yeah, I mean, because any process we can turn into a quoted process.
Yeah. I didn't try it, so
because I think like the co-ops Rolang even uses like their hash verify functions are at quote or like their sig verify is like at quote ed25519 verify. That's the channel you send on to do those things.
Oh yeah. You mean you are quoting string? But I mean, I want to quote string as a string type. String.
Oh yeah, and you can do that as well. You can do that as well.
Ah, cool. I didn't.
So the difference between something like nil and a string that may even literally say nil is that when I turn it into my structural type, both of them for this string will say leaf because those are both things where the structural tree ends, basically. But for the nil process, it'll literally tell me that it's the nil process in this second coordinate, whereas with a string, it'll literally tell me it's a string.
Cool.
Right.
Cool.
In both cases, there will be a string in the third coordinate, but it's the second coordinate that differentiates them, basically.
Oh, I understand.
Okay.
And can you say something about and? Because you cannot use and anywhere else, right? Except in the pattern. Is this true or?
Oh, you're talking about like logical connectives between processes.
Yeah.
Okay.
Yeah.
I have not gotten to that point, but yes, you can only use and in patterns.
Because I'm thinking that maybe it would be useful to have a custom definition for these kind of things. You know,
what are you thinking?
If I could define operator on for like a binary operator, and is a binary operator which accepts two processes and outputs process.
Okay.
So if we can define custom operators, that will be very useful.
Mm-hmm. Oh. I mean, we can, in my definitions, like I can make up whatever I want, basically. I'm trying to make up things that are consistent with things that already exist, I guess. But we can experiment, like when Joshi was talking about like using only processes in the row calculus. I was like, oh, I could definitely write that up in K. Like, why not? And it works pretty similarly to like the typical row calculus. And so for me now, it's like a really interesting question to figure out, like, what exactly is the difference between having only the processes and like having literally another distinct entity called names.
Yeah, that is very interesting.
Yeah. So either way, what it turns out with this depth function is I have to do like almost 2 instances of induction at the same time, or recursion, like whatever you want to call it. And I think the reason is because this depth function takes me from this sort type to integers. So I have to do some sort of recursion like in this sort and also some sort of recursion here. And I'll show you what I mean. So basically, if like all I'm doing is, my process is the integer 0, right? So the integer 0, its structural type will be of the form which I'm calling leaf type, which is basically it'll say type leaf. Since it's an integer, it'll say integer here, and then it'll tell me it's the integer 0, basically. So it'll have this form of a leaf type, and basically all I'm saying is that I want the depth of that thing to be 1. I could have made it 0. Either way, it doesn't make much difference. But I'm calling it 1 just because it's literally a vertex. It's a binary tree with three vertices and 2 edges, basically. So that has depth 1. I'm saying. I also need to tell it that if I give this function, well, actually, let me skip this part and we'll go to the next rule, and then I'll come back. So the next rule is basically saying if I have some nesting of my types, like if there's more expansion that I have to do, like it's, par, and then within the par, there's, some other stuff that I have to expand, then basically what it's going to look like is it'll say type. It'll tell me like the top level term constructor here, which is just, written as a string. And then there's like two lower level types within it, basically. And this is just for like whatever the first term is in the par, if that's what I'm looking at, and whatever the second term is in the par, if that's what I'm looking at. And what it's going to do to compute the depth of this is exactly what you would think. It's just going to look at the maximum depth of each of these like subunits and then add 1 to it. So it'll go 1, these are integers and I'm adding integers. And so I'm going to add 1 to the maximum of the depth of A and the depth of B. And it's interesting because
Isaac, hang on a second. I don't understand the rules on 39 and 43. The ones on 40 and 44 make sense. Like the depth of something that's a leaf is 1, but like on 39, it looks like you're just saying anything that's a leaf can be rewritten to 1. Not that its depth is 1, that it itself is 1.
Yeah. It's interesting because so we're defining a programming language here, right? So what these programs are going to look like in this programming language is they're basically just going to be fed a type. Let me see if I have some of them up here somewhere. I had a bunch of them open earlier, but either way. Yeah, so they're just going to look like this.
Oh, that's pretty hard.
So for example, I don't even know what process this came from, but either way, that's some structural type. It doesn't even matter what those words are. But either way, it's like, type, apparently it's a par is the top level term constructor here. And then within that, there's like some ends. I don't know. It's some junk that's like deeply nested. But either way, this is what the programs are going to look like, right? So basically, it's just going to input this structural type, and then as the output, where were we? Here we go. And as the, come on. Oh, that was really weird. Okay, either way, I don't know why my screen just changed colors, but yeah, and as the output, it is going to give me an integer. So input is just going to be a structural type. That's what I have it saying here. Like the configuration for this is really simple. It's just one K cell. That's it. All it takes is the structural type. So I'm telling it once it parses that original program, it should be of the sort type. And then what it's going to do is just reduce that type. That's all it's going to do.
Right. So why would you want to? Why would you want to reduce that type to just?
Yeah, and are the different structural types have the same integer?
Can different structural types have the same integer? Absolutely, yeah.
But I'm not sure then what this integer means.
Yeah. So all I was saying is like how deeply nested can any term get in a particular like Rolling term or something.
Oh.
So it was supposed to be really straightforward and simple. But what happened was something kind of interesting, and I don't know if you guys have seen anything like this before. But either way, so Joshi, did I answer your question?
I mean, probably. I don't feel like I fully understand it yet, but maybe I'll see. But another question that I have now is, what's the difference between a leaf type and a terminal type?
Yeah. Okay. So a leaf type is a terminal type, first of all. So that's what I'm saying here. But a terminal type can actually have a slightly more general form, and here's the more general form of a terminal type. So it can be some sort of type with some top level constructor where each of the branches are terminal types. Dang it, I had a bunch of pictures for this. I actually drew a picture. I don't know if it would be helpful. I'm straying a little bit far from just showing you guys this depth function, but does that make sense though? So terminal types can be of two flavors basically. One of them is it's literally a leaf and it's just like this like two-pronged fork or whatever, or a terminal type can look like this. It can have some top level term constructor that I'm writing as a string here, and then each branch is also a terminal type.
For me, this is very difficult to parse.
I mean, well, okay, so think about it like this. It's just a recursive structure, right? So a terminal type can have it, so it can be like one of these ground types, which is just the leaf thing that I'm talking about here. So like,
but I'm not sure that I understand definition of this this line.
Definition of,
you are saying 43 of this second definition of terminal type. You're not saying terminal type equals something. You have arrow.
Oh yeah, so this highlighted portion, that's just pattern matching on a terminal type. Right, so like I said, terminal types can be one of two flavors. Here's one flavor, a leaf type, or it can have this flavor, which is string terminal type.
Are you defining this type here?
I'm not defining the type. I'm just defining the depth of the type.
So you keep saying terminal types can have two flavors, but on line 23, it looks like they only have one. That's one of the things I'm stuck on.
Oh, yes, because I'm also importing the syntax from this other module. Yeah, sorry. Oh, I am so sorry. This is not the full definition. I totally brushed that off at the beginning. I was like, oh yeah, this is like the stuff we were talking about a full week ago that I've been thinking about every day, and you guys probably haven't thought about for a week. So I apologize for that.
No, that's okay. Okay, so on line 23 though, like when you say terminal type : equals leaf type, that means like in addition to what other stuff it already equaled in the import, it's not like not like replace that stuff with just leaf type.
That's right. That's right. Okay. Yeah, this is just saying let leaf type be a subsort of terminal type.
Okay.
Yeah. Yeah, which I'm writing over here. Which either way, and that's what led to those diagrams. But I need to come up with like a really nice systemized way of presenting that stuff. Okay. Yeah, so, oh, maybe I should, dang it, maybe I should show you the syntax for the structural types again.
Please.
Yeah, sorry about that. You know, like I said, man, I've been thinking about this stuff basically every day for the past week. And so it's just like, oh yeah, of course we're talking about leaf types and terminal types. But yeah, you guys need to see all of this, I forgot. Okay, sorry, I'm gonna scroll down to the important stuff. Okay, so with types, they can come into three different versions that I was saying. Basically, it's like initial type, and this is when we're doing the expansion of the rolling term into the structural type that it has. The original form that we put it in is this initial type, and I'll show you what that looks like. I'll just show you right now. So basically, it can either look like I just want the type of something that can either be a name pattern, a process, or a process pattern. So I call all of those things or pat because it's just like, well, it's anything or it's a pattern basically. Or it can just be a type of a leaf or a binding or pattern. This stuff's not super important. It's just for to actually like implement the structural type system. But either way, so the types can be like initial types, which are basically just like inputs for this thing to turn it into the structural type. There can be this intermediate type, which is basically just like as we're expanding different pieces into their full like structural type. This is just what it looks like. It's not fully done expanding, but it's started expanding basically. So by the way, these intermediate types, they can start off as initial types, and then they can enter into this like immediate, intermediate type version, and then they'll ultimately end up in this thing I'm calling a terminal type. And a terminal type is literally just a fully expanded binary tree, exactly the way you would think it would work for like keeping track of what constructor is like piecing together these two pieces that you're looking at. And that's basically it. That's how the structural type system works. At least we're trying to everywhere we see something like type of some process, like nil or some integer 2 or something, we want to expand it into stuff that looks like ultimately like a terminal type, which is just like the fully expanded binary tree. Does that make sense? You guys have questions?
At some point, you were going to show us something that kind of worked, but didn't totally work.
I wanted to show you something cool with this depth thing, but I'm wondering if I'm getting too far away from that. I mean, all of this stuff is related, but I'm wondering if I'm straying too far from like the original thing. Okay. Either way, let me talk about this a little bit again. So I wanted to define this function, this depth function, that takes one of these structural types, which is just a binary tree. Like that's all I'm thinking about when I think of a structural type. I just have some binary tree. And basically I want to just like compute what is the longest branch in this binary tree. And so what I want it to do is take one of my structural types and output an integer. Right, so this is one way to do it. So this is a way I've been defining functions, is basically just by saying like, here's some new syntax. It's hashtag depth, and with some parentheses. And in those parentheses, I can put a type. And what I want it to do is be an integer. So I need to give it some rules. Like this is pure X, I give it some semantics. So what I want it to do is, I don't even need to put anything into that. I don't even need to call this depth function if it's just a leaf, because no recursion needs to happen, basically. So if all I have is like the integer 5, then that's a leaf type, and I can go ahead and just say the depth of that thing is 1, because basically there's 2 branches, each have length 1. So if it's something more complicated than just one of those like ground types, like an integer or nil or something like that, then it looks like this, right? So I'm just doing some pattern matching. So if it's not like the ground case, then it looks like this, because I know it's in the terminal form, because that's the final form from that structural type function. So when I see that I have a terminal type that has this form where it has these 2 branches that are also terminal types, then like I said, it's basically like a binary tree where I'm looking at the top vertex, and then it branches into 2 things that branch into more stuff, but all I'm saying is for that top vertex, I want to add another 1, and then I want to add that to whatever the depth of those kind of like subtrees are. And so now something interesting has happened, because here I was just like, oh, if it's a leaf type, give me a 1. But now here I'm like, okay, if it's this more interesting terminal type, then give me 1 plus this depth function called on the subtrees. So now I have to define this depth function. Okay, so the depth function, if it's given a leaf type, just gives me 1, exactly the way I would want it to. But if I call this depth function on a more interesting terminal type, one of that has terminal type for each branch, then it's going to do exactly the same thing. It's going to do 1 plus subtrees. And now it works. Yeah, but
So
have you seen something like this before?
Definitely recursive depth recalculation is pretty common, but something about lines 43 and 44 seems weird. Like 44 seems like it's probably correct. Like the depth of some big thing, 1 plus the depth of whichever of its children was bigger. Line 43 seems like, again, I don't know K-framework at all, but it seems like it might be a mistake, because that seems like you're saying you're not saying the depth of this terminal type is 1 plus whatever. You're saying like this terminal type is 1 plus whatever, which might mess up future recursive calls.
Or you mean without 1, right?
What was that?
You mean without adding 1?
Well, I guess I'm just saying like, well, okay. I guess what I'm saying is like, imagine we're talking about weighing humans. It makes sense to say like the weight of that human is 80 kilograms, but it doesn't make sense to say that human is 80 kilograms. Well, okay, in English, that's how you parse that sentence. But like the concept of a person and the concept of 80 kilograms are totally different things, right? And it seems like 44 expresses that correctly, but 43 confuses humans with kilograms.
Mm-hmm. Well, so remember
that's what I'm wondering.
The only thing that this programming language is doing is taking in one of these structural types and giving the depth. That's all it does.
So what? Well, I thought that's what your pound depth function does. Like it should not rewrite.
So the really weird part was, and like I didn't think that I needed all of this stuff. I was like, no way. Like I should totally be able to just get away with the depth. And maybe I can like change what type of input program I have or something like that. It's possible. I haven't experimented with that. But currently it makes sense the way that it is, only because this depth function goes from types to integers. So like, I'm just saying, anytime you see a leaf type, just tell me that's 1, right? Because all I want my program to do is like, given a structural type, give me the depth. So it makes sense that.
Then why? So let me ask it this way then. Why did you ever bother to define the depth function on line 19 if you're just going to directly rewrite structural types to integers without calling depth?
Yeah, it's interesting because how do I rewrite something like this directly into integers? Because like with the leaf type, I totally could, right? It's 1, fine. But at that point, now I have like, once I have more complicated structure, I need to do some sort of recursion.
So, okay, so let me ask you this. So imagine you start with something really deep, right? And so the first rule you apply is rule 43.
The first rule I apply is rule 43. That's right.
Yeah, yeah. Then you're left with something that looks like 1 plus 2 calls to depth, right?
Yeah.
And in place of A and B, there's going to be actual other terminal types, right?
Yeah, that will more or less, they'll either like this or they'll be a leaf type.
Right.
Yeah.
So what you want to happen in that case is that you then apply rule 44 to like pound depth of A.
Yeah,
right?
As far as it goes until A and B are just leaf types.
Right. But you've also still got kicking around in your set of rules this rule from 43. And so rule 43 might be again applied to A directly. And so now, maybe that's still okay, because it still says depth of depth. Well, no, that's right. I think that's the problem I'm getting at. So assume that rule 43 gets applied first. That's fine, and we both agreed. Then when you later wanted rule 44 to apply, you instead applied rule 43 to just the A part, not the pound depth of A part. So now what's left is pound depth of something, like maybe 1, for example.
Yeah.
So I'm wondering if that's where you're getting stuck.
Well, no. So this program works actually, but
I thought the whole purpose was that we were debugging your depth function.
Oh, no. I was showing you this because I thought it was really weird that I had to do like basically 2 recursive calls to make this work.
Oh, no, that makes sense because you've got 2 children, right? It's a binary tree.
Well, by 2 recursive calls, I mean
2 rules.
2 rules basically, like 2 base cases and 2 recursive rules.
Yeah, I understand depth when you're defining depth and recursion with depth, but if you don't, where is your cursor? I'm not completely. You're saying, okay, if there is a leaf, I will return 1.
Yep.
And can you use? Why is this necessary if you have definition for depth? If you supply it with a leaf, I will get you 1.
Yeah. So I think this all came about because I wrote this in a weird way, in the sense that the input is always going to be a type. Like I have to literally put a structural type into this. Like that's what the original program should parse as, is a structural type. And then ultimately it's going to end up as an integer. I didn't have to do that. There may have been a better way for me to do that. I'm just not sure how I could have done it.
Oh, you're saying you're not always counting depth. You can just have a type.
So
you must say, okay.
The original program, so something that I would run, so here's a dot depth program, right? So it just takes a structural type. So this is
okay. So this whole thing, this entire depth.k, job, is to take a structural type and give you back an integer.
Bingo. That's it. That is all that it does.
Its job is not to parse programs which could do lots of different things. One of which is counting the depth of a binary tree.
That's right. Yeah. This is just it's a module, right? Like it's a little piece that I might be able to like import into a program later on if I need it.
So I'm curious now. What can we go back to depth.k real quick?
Oh yeah, definitely.
Okay, so what if let me say the whole thing first and then see if you think it's a good idea.
Okay.
What if we completely delete lines? Can you make that a tiny bit bigger?
Oh yeah.
Yeah, what if we completely delete lines 40 and 44 or comment them or whatever?
Okay.
And then we change 43 so that instead of rewriting to 1 plus blah, blah, blah of depth of A, depth of B, we just rewrite it to 1 plus int, max int of A comma B.
Yeah, that isn't proper syntax though, because A and B are terminal types that may not be leaf types.
Okay, yeah. Now
Right.
now we're back to where I don't fully understand the data structure, I think.
Yeah. Okay. I'll draw a picture. Dang it! I have so much crap going on this.
Oh, but are you saying that you cannot say A here because you must convert it to integer? You must call that on A.
But doesn't that just mean we're going to reapply a different rule?
Yeah. This is my question. We have a rule for terminal type.
Oh crap! Where am I? There we go.
Oh. But yeah, we don't have a rule just for terminal type.
Oh, dude, and okay, and I didn't realize we had to do this explicitly. So in addition to the changes I suggested earlier, what if we add strict to line 43?
Add strict to line 43.
Is that an evaluation?
I don't know.
strategy?
Yeah, strict is an evaluation strategy. It's just going to tell me, like, don't stop doing this until this thing that I'm calling on, reduces to integer, basically.
So, okay, but it doesn't mean evaluate the args before you evaluate the function, or like apply rules to the args or something?
It can, but not when it's an attribute of a rule. When it's the attribute of a construct, then yes. But I didn't use that here because I wanted it to take exactly the structural type, not do anything with it, and just give me the depth from that.
Gotcha.
Oh, but either way, let me draw some pictures. So a leaf type, there's probably a much better way for me to be doing this. But a leaf type just looks like that.
Can you stop sharing your screen for a sec?
Oh, yeah, sorry. Dang it. There we go. Did that do it?
It did not.
I think you're still sharing, but yeah,
Oh,
I can expand.
I thought I could pause.
Josh, you can expand.
Oh, okay. Hold on a second. I'll just stop there.
I didn't know I could expand. That's my bad.
So that's what a leaf looks like, right? And the top vertex is just like, it just says leaf, and the bottom two vertices, we'll say like int 0 or like bool false, something along those lines. Right, so like,
and nil is a 0.
yeah. So here's for nil.
Oh.
So nil will just say leaf, and then it'll say nil, and then nil as well. But the reason, so I end up with a string in that bottom right, portion. But I can differentiate it from a string that says nil, because a string that says nil will say string here.
Oh, I see.
Yeah. So either way, so that's what a leaf type looks like, and that's why I was saying, leaf type should have depth 1, because it's like, okay, there's only, there's 2 branches and each of them clearly have length 1, right? So that's why the depth of the leaf type is 1. Okay, so but either way, a terminal type might be something like, quote, nil, oh yeah. Okay, and to make everything a binary tree, we add this goofy thing in called truncate. One second. And truncate.
So leaf and terminal is like labels on this binary tree.
Yeah, exactly. It labels the vertices of the binary tree, the nodes or whatever. So this would be like quoting the nil process is how it would look as a structural type. basically quote is like the top level term constructor, and then that branches out into, well, the leaf that is the nil process, and then also that other leaf is just like to make it a binary tree. It's just like some, added, add-on thing called truncate. But either way, so this is a terminal type, and the reason it's a terminal type is because these guys are each leaf types. Leaf types are terminal types, and this is some string that branches out into two terminal types. So this is a terminal type.
Oh, you need the second leaf just because you want to have binary tree.
Yeah, exactly. Just because we want to have
truncate, it means it's not important.
Yeah, exactly. It means like quote only really takes one thing, and that thing happened to be nil in this case. The rest of the junk doesn't really matter. Yeah.
Oh, I see.
Yeah. Yeah, so this full structural type is a terminal type currently, the way that it is.
So it sounds like maybe we have a polymorphism problem, because at some point you're recursing through these terminal types and you get down to what really is a leaf type, but the type checker only knows that it's a terminal type. It may not, the type checker doesn't know that it's a leaf type or something like that.
Why do you think so? I'm not sure that I'm following the question.
Wasn't the problem hold on, I got to figure out how to see the screen again. Okay. So yeah, like at some point the problem on 43 was like, Isaac was saying it wasn't valid syntax or something, or was it definitely syntax, or was it a runtime thing?
Just to like go ahead and put this here.
Yes.
Yeah, this is not okay, because it already knows that A has. At runtime, it knows that A has sort terminal type, and I'm calling max int on terminal types.
But okay, so hang on. My question though is. So here's the thing. I think we need to decide once and for all, like whether we're going to use the depth function or whether this whole program's purpose is to just like take in a terminal type and give you back an int. Because so you're saying like
my claim is that you have to do both.
Can you define a rule for terminal type which is almost the same as a rule for leaf, and just say, okay, if you have terminal type, call the depth of this terminal type.
If you have terminal
similar
type.
Question.
Yeah.
Similar question. If for the leaf type, it's easier. So if on 39, can you say in a rule for a leaf type, can you instead of one call depth of this leaf type?
Can I instead call depth of this? So are you saying just like get rid of this completely?
Not completely, but just call the depth of this leaf type. Is this like possible to say?
So here's one thing that I'm not sure that I can do, but maybe I can do. So I can just make it so that this program always parses as something that says hashtag depth with a a type inside of it. And maybe that's something that I would want to do, but I'm not 100% sure how to do that. Maybe I could just make sure that it always parses as an int or something. I really don't know, honestly.
Okay.
I was thinking that if you name this leaf type like A, and then call depth of A.
So I just want to call depth of A. Okay.
Yeah. And I'm thinking that if you do this exactly the same for terminal type, then you can then maybe you can do what Joshua was suggesting. Just say max int of A, comma B. This makes sense.
Oh, then you're saying here just do this now instead.
Yeah, but I think you need to define the rule for terminal type. Just as the rule for leaf, I was thinking the same for terminal.
Same for terminal type. Okay, so when I call, wait a second. So when I call depth on a terminal type, I should basically just be doing this.
Yeah.
So then keep it like this.
Yeah, but you're missing the rule when you have terminal type to call depth on this terminal type. I mean, just repeat the rule for on 39,
Yeah.
but for the terminal type.
Okay. Yeah. Right. So just when I have any terminal type.
Yeah.
Yeah. Just rewrite that to the depth.
As I understood you said that, okay, I cannot supply directly, but now I have the rule.
Yeah. Oh, right. So you're saying that should now make it so that I can totally get rid of this.
For that, I'm not sure.
Well, let's see. Do you want to see if it works?
Of course.
All right, cool.
Yeah, I at least want to see what the error message is when we try to put A and B in the
I've been getting a lot of these freezer syntax 0. This is an interesting one. Syntax 0_2. I'm trying to understand what exactly that error message means. I was getting some other weird syntax 1, and it means something slightly different, but either way. All right, let's compile that.
This is a great way of learning. You just say to someone, try this.
Yeah. It says unexpected sort terminal type for A, expected int.
Mm-hmm.
Expected int where? Oh, here.
Yeah, but it has the rule that if it's found terminal type, just count that.
So it seems like the evaluation order is when you have one of those max ints on the right side of an arrow, max int gets evaluated as part of the rewriting. It doesn't rewrite with to maxint space paren space whatever A was. You know what I mean? It tries to immediately do that.
We could make a construct. I mean, we could just define another, hashtag max int and then make it do exactly what we want. But I don't know if that's better than what we had before.
So let me ask you this though: is it an absolute necessity that the description of this thing takes in a terminal type and gives back an int, or would it be acceptable for it to be takes in $depth space then a terminal type and gives back int?
Well, so I don't think that I can write that here. You know what I mean? I don't think it's valid for me to say this or anything like that.
Oh, it's not.
Oh, I don't know. I mean, let's try it.
Yeah, let's try it. Yeah.
I've never tried it, but you got to try everything once.
Got to knock it before you rock it before you knock it.
There you go. Let's see if it.
So remember though, before we decide that absolutely doesn't work, we have made other changes too.
Yeah, except it does tell us now we literally just introduced a new error on.
Oh, okay, guys. So inner parse error, unexpected token :
Yeah,
so that was a parse error. So
yeah, well, I think it's because I then went to do pound whatever afterwards.
What if you do,
I don't know. Let's just get
depth of $PGM : type.
What's that?
Pound depth left paren $PGM : type.
Oh yeah, all right. Oh, that would be cool if this works. Actually, I've never tried to manipulate the way the program is parsed.
I think you might want a pound in there.
Oh, did I not do that? Damn it.
Yeah, this would be cool.
Come on. Save. You gotta save it before you try to compile it. We still need to change some stuff down here, but we'll at least see if it took.
Yeah, totally.
Oh, it looks like it actually did the pound sign, which is really strange. Okay, so let me see. Let me.
Oh damn! I didn't get to see the message.
It's working.
Sorry. I'm gonna undo all of this other stuff to the point where it was working, and then see if it will be okay with saying this. Because otherwise, it's just going to give error messages for something else. Okay.
Oh yeah, last time it wasn't until 44. Yeah, nice.
Yeah.
Well, yeah, it was still the same thing where we were calling max int on something of terminal type.
Yeah.
It compiled.
Right.
So let's try to run something then.
Okay.
You have a preference? Let's do par type. Oh, I should get an error. I don't. That's really strange. I'm not convinced this is doing anything. I don't know why it's not doing anything, but
what makes you think it isn't?
Because it's doing exactly. So here, I'll remove it and show you.
No. Can you remove the 39?
Dude, remove 39 and 43 and you're done.
Remove 39 and 43, you think?
Yeah. Right? What do you think, Tomislav?
Yeah, definitely.
Or now it's 42. Yeah. Right.
Oh, actually, I want to keep the strict though, right? There we go.
Yeah.
No.
Wait, hold on. No. That was the wrong one.
No.
Was it?
With the depth.
Oh.
Yeah.
Oops. This one.
Yeah. It switched line numbers after we deleted that squirmy little bastard was moving around.
All right. Let's see if this works now.
I don't understand the syntax of K-framework, but this looks like it should work.
Neither do I, man.
The depth is defined, and we are specifying all the rules. If this makes sense.
It still works.
That looks pretty promising.
Cool.
Yeah, hey, it still works. That's not bad. Let's check out something else.
But you didn't compile it.
I did.
No, yeah, you did.
Oh,
right here, right before I ran that last one.
You just couldn't tell because there were no error messages.
Oh yeah, I forgot. I don't remember if I had a bunch of error messages last time, but yeah, I recently updated it and it got rid of all the error messages. And if it didn't
you updated K and those warnings are gone?
Yeah, dude, exactly.
That's great.
If it didn't do anything else, I'm just happy that it took the warning messages away. This definitely looks like it's working. Now,
nice, dude. That's great.
Yeah. So, okay, let's take this out and see that it gives us some error messages, right?
Yeah.
Because it definitely should, because I'm feeding it here we go. I'm feeding it this, right? A structural type. Like it should be like, whoa man, that's not wait, oh actually, hold on a second.
It's gonna give you exactly that structural type in a K cell, I bet, because you don't have any rules for how to reduce them.
That sound, let's make sure that's what happens.
Yeah.
Or is this an error because you didn't define what to do in this case?
So there aren't a lot of legitimate errors in K, except for you literally told it to do the wrong thing, because it'll just compute until it gets stuck. And then it'll just be like, here's where I got stuck and here's what I computed, basically.
Okay. So in this case, it will just print what is in Excel.
Yeah.
Oh, yeah.
So I think it just took your whole input, jammed it into a K cell, said like, well, I don't have any rules that apply. I guess we're done after 0 reductions.
So I'm wondering.
But where are you getting this syntax 0?
That's really interesting. What's that?
In output.
Syntax 0. I'm not sure.
I didn't notice
It almost looks like it's trying to reduce or expand or something these structural types. Like this almost looks like an error message from I can even show you. This almost looks like an error message. Maybe I don't have it in here. Dang it. No. Dang it. Those are just other error messages. All right. Either way, yeah. This looks like the error messages that it's giving me when I'm working with this untype function that I'm trying to build. Weird. I'm not sure why it's giving me that particular error message, but it certainly looks like it's because we took this off of here. Which that's really cool. I didn't even think to do that. So I was like, how can I, work with this stuff when it's two different sorts? But yeah, just throw it into the depth function right from the beginning, right? Yeah,
you can do.
That totally makes sense. Well, apparently you can do that double recursion stuff too.
Yeah.
I've never seen that before, and I was like, I don't understand why I have to do this, but it's working. So that's interesting. Looks like it's fixed.
Yeah.
Yeah, cool.
Right.
Wow, that's great. Okay, cool. So I can just throw the program directly into whatever function I want right from the beginning. That's pretty cool.
That is cool.
And
All right, gang. I'm gonna head out, I think.
Yeah.
do you must use hash for defining function or this?
What was that?
Do you must use hash when defining function for depth, for example?
Oh,
Use hash sign on the beginning.
yeah. So okay, I'm not 100% sure. Let me just say that because there is designated syntax that is very similar to what I have here that I think is specifically just to be used in the semantics module. But that's not what I'm using here. So like if you're asking if I should just be able to like delete that pound sign and do this, I believe that I should be able to, yeah.
Oh, okay.
But I mean, I don't know. We might as well double check, right? Just to see for sure. So it shouldn't be a problem because I'm just defining that notation up there, right? I'm just defining the syntax. So it should do exactly the same thing now, which would be great.
Oh, I see. Oh, yeah, you're defining syntax.
Yeah. Perfect.
Nice.
Yeah, because here I'm literally just saying like attach the word depth to some type in parentheses, and then that's going to give me an in, right? And that's just the syntax. But the semantics is like, okay, if that's a leaf type, give me a 1, and if it's something you have to recurse over it, and just give me the answer basically. Yeah, this is cool. This is so much better than it was. I'm glad you guys helped me with that.
Yeah, cool. I definitely learned a lot. Yeah.
Oh, great. Yeah, sorry to be so confusing at the beginning. Yeah, so this stuff, it's complicated. It's a little bit hard to talk about, right? Because it's like recursive data structures are already confusing, and you're like terminal types have terminal types in them, and then you're like, what are you talking about? So
yeah. I don't know anything about K framework, so
Yeah, it's interesting, man. Like sometimes I think I know things, and then I realize very quickly that I don't, and then sometimes I don't know why things are working the way that they are, and they just do. And like you saw with this example, like that stuff was working. It was clearly not the best way to do it, but like it was definitely a way to do it. So, no.
Yeah, I have similar experience with parser.
Yeah.
Sometimes is it working or
Hey man, that's the learning process though,
Yeah.
Yep.
Cool.
All right, guys.
Oh, Josh is not here.
No, I think he bailed already. Yep.
Does anybody have a minute to look at a Roline book?
Rolling book?
Yeah.
Sure, man.
Sure.
Awesome. Okay.
Oh, yeah, let me.
The situation is this. Okay, I have a file. Oops. I have a file here. Locker.row.
Jim, can you share the screen?
Oh, I thought it was. locker.row, and this file is slightly different from Dan's version of Locker. Okay, and the differences, whoops, the differences are that, oops, I didn't mean to execute it. Where they do that. Weird. I just want to do a diff. Okay. Differences are he had a standard out here with a map. Lockers wrote say that, and I changed that to a define, so it would define the macro locker to be the URI.
Mm-hmm.
And the other change was we made before. We added a making locker to it to try to debug this. Okay, and here's the where I changed the standard out. And here's where I added the trace, making locker, because basically what is not happening.
Yeah, we don't see this call, this receive.
Right. Well, in our make locker here, we're calling the locker here. And when we call it with Dan's version of the locker contract, we get it.
That's strange.
Oh, is that the one? No.
But the difference is only how you print this to standard output.
Right. And no, I mean it's totally baffling. It just silently, well, it never satisfies this, so it never.
And you don't get the trace that you added to locker.
Trace, right.
So definitely this send is happening, but receive is not happening.
Well, somehow
So
it's as if this locker match that never happens. Now, I'm using this dollar locker variable here, which we should be able to verify is the right thing. I don't know if I assigned it here.
Jim, can you display the locker channel? Because
okay, this is running Dan's version here. Home Dan locker.row. Okay, and we get this URI back here. And then I define the locker 6x05, 6x05, maybe in Z3. So it's as if so when I define the locker, and I guess I did that in the other channel. In node runners. where I defined that. Okay, here's it working. Oh, here's where I defined the locker, and it the test program works. With my version of it. But then when I do make my locker, it finds the locker, it never calls the contract. Okay, this is the version that defines it for me. And we had this problem last night and this morning. And,
what we don't see here is this locker channel that we get from the repository. Just in this place, when we receive and when we send the public key to locker, we send the return channel, which
I'm not sure.
But what I'm thinking is maybe we get something else from a repository somehow, because we definitely get something from repository, right? Because found locker is printed to standard output.
Okay, so. So this is Dan's version. Oh, it's not the bottom. I'm not at the bottom at all. Really. Get to the bottom. What do you suggest I do?
I'm thinking this call to this locker channel. So yeah, locker channel is where is the locker channel defined? Locker channel.
Well, the lock
somewhere up, or this return channel that we supply to locker. It's not defined in this new.
Yeah, that's what?
No, not in the locker file, but in the file that creates locker.
Make my locker.
Yeah, and this locker channel, where is defined? That we are sending to locker. I don't see it. This channel that you are sending with public key.
Yeah.
I don't see where
we
is
have a lookup channel, and we don't have.
Oh! One line up. Yeah. This is the locker channel. Yeah, we are sending on locker channel. It's created just one line.
Right here. Yeah.
Yeah, on top of the locker. Yeah. So that should be fine. We're creating new channel and just supply to the locker. Huh.
I mean, that's.
Can you display to here found locker? Can you display the locker itself that we get from registry? This unforgeable name. Just one line up from the cursor, And instead of just found locker, we can display exactly the unforgeable name as a map. Yeah, this can be found locker can be a key. Yeah, or array. Yeah, at least.
Yeah, I started a list, so.
Yeah.
Oh yeah.
Maybe we get the wrong locker. I'm not sure what does it mean to have wrong locker.
Okay, so.
You need to close the parentheses from of list. That should be
the list. Okay, well, so.
And this should be the same address that is registered with that the locker is registered on registry, right?
Right. Now, right now, I think I have Dan's version defined. So let me include my version. Okay.
Okay, this is the address that we are looking.
Okay, and now I need
Make locker.
Yeah. Well, I can do this. I can do a echo.
Oh, make my locker.
And you can see the MJAZ3. Oh,
But this is not the correct code.
I have to update this.
Okay. Oh.
We have to do. I suppose I could run it here for dummy user. Row exec, send, and don't need an argument. What has it been, 7:15?
Oh, we are trying to display a name. Yeah, it must be evolved. The locker. The locker is the name, not the process. Yeah. So it must be evaluated with a star.
I'm missing something. What?
Yeah, two lines up from the cursor. The locker is a name, so it must be evaluated. So it can be a process. Yeah, exactly.
But that
with a star.
That isn't the error that we got, is it?
Exactly.
We didn't get. That's not the error we got, right? Oh.
No.
It says illegal character $sign at 7:15. So.
But this $sign doesn't mean you have $sign somewhere. Mm,
Yeah, it sort of does. If we look at what was generated here, 1, 2, 3, 4, 5, 6, 7, 15. My pub key. So my
oh.
pub key is defined.
Okay, but the locker is definitely wrong. So now it's correct. But this is the like the first error, the parsing error.
Yeah. Well,
But why is this? Oh, so it didn't replace.
it didn't replace my pub key.
Yeah.
I don't know how that could be. Dummy user.h. Oops. I didn't write it. Let me just do it again. The heck with it. Still the same thing.
What did you do just before this? You evaluated the dummy user H file, but not successful.
Dummy.h is where it defines
But something was not correct, I think.
defines the priv key.
But I'm not sure if you imported this. There was some kind of the red error or something. I didn't see it completely.
What do you mean?
Can you import the dummy user again?
Import it again?
Yeah. Because I seen some red message, but I don't know. I didn't see it.
Yeah.
What it says.
So this is where it's included when we run the exec-bro function.
Yeah, can you do it again? I mean, I'm thinking that maybe it's not important. No, maybe I'm wrong, but yeah.
Whoops. Oops. What? Evaluate
So
dummy user.hx. Unrecognized interpreter error.
this is a syntax error, but we don't see it because it's rendered on the standalone node. Oh, yeah.
1-0.
Yeah, this looks like that the code is not replaced. So the error is on the first line, on the first character, because
Pound include is not working here, huh?
yeah. But not only include, it seems that preprocessor didn't do anything.
Well,
Can you just run the preprocessor?
my username, replace this. Dummy user put here. So my pub key.
Oh, you're saying this is the file that is preprocessor are generating?
Right.
But this doesn't make sense because there is a syntax error on the first line on the first character.
Oh, yeah, this end is removed.
Yeah. But the file that is sent to our node definitely has some syntax error on the first line on the first character. So we are not looking.
I took that out. Okay.
Oh, you removed it.
We didn't see that. Okay, the underscore new is not there. The underscore and underscore is taken out. And so the first character in this case is a new. And
but we get the error from in the browser.
That was when I had the include in here.
Okay.
Okay, so now, you can see dummy user is replaced here. My username, dummy user is replaced here. My username.
Yep.
But the
pub key is not.
My pub key is not. Oh, that's bizarre. How could that be changed? How could that not work?
But can you define my pub key?
Hmm?
Can you just define my pub key? Just for test. We can put here anything we like, right?
Yeah. Oh. Define my username is here.
Yeah, but can you put my pub key also?
I wonder why. I never have to do this normally. I don't know why I would have to do it now. Weird. And what? Oh no! I just overwrote dummy user.h somehow. I said E, dummy user.h. And why is this have all this code in here? That's bizarre. Now it's gonna. So this is the original dummy user.h.
But here you don't have my pub key defined.
Oh.
Here is just my here is just my private key, but not the public key.
That would explain it. How did it ever work?
But this is not the original error.
Yeah, well, when we run this in Discord, it's defined.
Yeah. Can you now run?
Uh, Three variable inbox channel is used twice as a binder.
This is also something new. Can you show us the code?
Yeah, this may be different from what's defined in Discord.
So inbox channel is not defined. It's not created. Can you put it somewhere? Yeah. But why is this missing now? That's strange.
Weird.
Yeah.
Capabilities is not defined. 14. What? Oh.
How is it possible that now these things are missing?
I don't know.
Hmm.
What's this S here? Where did that S come from? I don't know. Oh,
Yeah, you need S. You need S on the end. Yeah.
okay. Oh, not bang bang. Yeah, already 6%. And I'm missing.
Also the same. Yeah.
I'm not sure. Obviously, what was defined. Okay, now it works. I think.
But
Locker found, making locker, made locker, defined, dummy user locker. Okay, so that. So this
but
is.
can you run it from Discord?
So we'll copy this. Where is it? It's the whole thing. Code J. This is make my locker. Actually, it takes no arguments. Now, how come I seem to be missing, not balancing here? Oh. Now I'm balancing. So if we, did we echo make my locker here? Yeah, we did. And This is definitely different.
But sorry, but are we looking the same thing or?
Obviously, it's not the same. And I'm wondering.
Okay, let's try this one. It's working for dummy user. So.
Oh. Didn't work. Oh, Jesus.
Now it's difficult to
didn't find locker.
But this is an indication, because we were thinking that found locker will definitely, when it's written, it's definitely found something. But yeah, it can be nil.
Well, we
so we didn't get a locker from the registry. This is why
this was the problem that we were having before. Now we can
you must check what are you sending to the registry when you want to find the locker.
This is the one.
But maybe in the code you are sending array instead of just name or something like that.
Okay, let me just verify. Oops. Okay, that's right. So we are doing, well, we can see. We look up dollar locker, lookup channel, and we read lookup channel. Okay, let's just do an echo.
When you display a locker, these backticks are added just for display, right?
I'm not sure. Oh, what is? Okay, this is showing spaces here, but those spaces aren't really there. Looks like I got another bug back in my formatting.
Oh, yeah, these spaces.
I don't believe the spaces are there. Now, what is this? Why is this having insert? Oh, it's just defined.
This is a definition, yeah.
Right. Okay, we can.
But when you see this lookup call send, you are sending on backticks, not on string. And I think you should send a string.
I never sent a string before.
Is this correct or no? I'm not sure. This is like a question. When you send
Yeah, no,
URI,
no, I've never defined it in quotes.
but this should be in quotes or in backticks.
Backticks.
In backticks, okay.
Yeah. But there's something wrong with the registry, apparently.
Yeah.
That's a problem yesterday, too. We put stuff in the registry, we wouldn't get it back.
Sometimes.
Sometimes.
Yeah.
So how could...
But is it possible that
we got something back, we got a nil back. It's telling us that this is not...
yeah, it doesn't exist.
It doesn't exist, but we got the value from the registry. Now there's one problem that I had.
But are you sure that you don't get these spaces? Because this can be.
Yeah, we could see that here. There's no spaces.
And this is what is sent to.
This is what it actually sent, right?
Yeah, and we can also see this in log, right?
Right.
Can you open the log and we can see there? Yeah. This is.
Now, this is interesting. Here's where we found it, the locker.
This is for dummy user, but now you're sending different thing. You're asking for different URI. Can you put?
So here we found the locker, and we.
But you're sending the same URI. Yeah, it's the same, right?
That we found and then we didn't find. So this was when we did the dummy user, right? Dummy user.
Yeah. But this code is almost the same. is the same address.
Yeah. So how could we find it one time and not find it the next time? Find it once, not find it again. Okay, the only other thing we've done is we've upgraded. Well, even before we upgraded, we had this problem. We lost our registry items. And that was the reason that I upgraded and started the database over again, because we lost our our entries. Now, it's almost as if, well, we read it and now it's gone.
Yeah, yeah. Can you again execute for dumb user? This can tell us something if
Execute what?
for a dumb user, because
Oh,
if
yeah.
this is the case, what you are saying, this will not work for dumb user again. So what is the output?
No.
Yeah. So you don't have a locker. It seems that it seems that exactly what you are saying. That the first time it's working with but it's deleted from the repository.
Now I'm wondering if I redefine locker, now
Do you need to define locker or it's already filled?
it's defined. It's defined by this.
Mm-hmm. Okay.
Okay, I'm actually starting to think about how we can do formatted output. I'm going to return variables in here, and it's going to give you a format. It'll do macros to format your output.
I see. When you're parsing the output, and when you have this list with defined, you're executing this, right?
Yeah. Deploy, propose. Okay, one of my hypotheses in the past was, what happened? Oh, okay. Now,
I'm not sure what did you deploy now.
locker. Well, the deploy just deploys whatever you last did.
Okay. So now you have a locker. So you can make your locker. And this will work for the first time and not work for the second time.
Nope, didn't work the first time. Well, so much for that theory.
Yeah.
Now, maybe the proposed deploy, I don't know. I don't know.
Yeah, I don't have any idea now.
Yeah, well, thanks for looking at this.
But yeah, we can continue. I'm thinking, how can I try it? So You said you have the code on the GitHub, right? Or yeah. For registry, it's very difficult to say because I didn't play with the registry. So yeah.
Should
We can
I?
continue. Sorry.
I have a feeling that the version of our node that we're using may have something to do with it. Maybe I should try running
With the older version.
the old version and see what happens.
Yeah, that would be useful.
So this is
Jim, I'm signing off.
okay. Well, listen. Oh, I really do appreciate.
This was like a long session for me. So
yeah, it's been all day.
yeah. But I would definitely like to continue next time. Yeah. So.
Thank you so much, Thomas.
Oh, no problem. See you next time.
Okay.
Bye.
See you later, guys.
Oh, you are here.
Yeah, I'm here. I'm in the background.
Oh.
I wasn't sure I was going to be able to help anyways, so you know.
I was thinking that you leave before. Yeah. No. Thank you for your presentation. Okay, it was.
Oh yeah, no problem, man. I'll be a little more organized next time. I wasn't really counting on presenting anything this time, so it was a little bit like haphazard and.
No, it was great. Yeah, it was great.
Oh, cool, man.
Definitely.
Awesome. All right. Take
See
it easy.
You.
Yep.
Bye. Bye, Jim.
Bye. Guess I should end it. And, see. Oh, boy. Hello? Oh, thank you. How do you know? Oh, yeah, I guess I did. Okay. Hopefully I'll be out in a minute. Yeah. Bye-bye.